A confirmation about the audio, please. If you're able to hear me out perfectly well, kindly confirm the same. Thank you. We shall be starting in a couple of minutes, guys. Okay, in the meanwhile, I'll take a couple of questions here. Uh, a question about how to write notes for current affairs. Not very much needed, my dear friend. If you don't have time for current affairs notes, you can always end up revising with the help of monthly magazines. So that is something which you can always accommodate. Vikram, you have a question about centrifugal force. Centrifugal force, in very simple terms, Vikram, is a force which acts away from the center. The planet rotates. So planet will have the maximum amount of speed of rotation where? At the equator. So that is where around the equatorial region, as the planet is rotating, there will be an outside push for the centrifugal force. And that outside push will end up pulling materials from both the regions of the polar areas towards itself, because that is where the tendency shall be to come at equator and then move out. And that is why Wagner said that is why the continents are breaking up. Question in drift theory, can you again in brief assumption of what? Assumption, basically, the assumption made by Alfred Wagner was uh, a couple of assumptions. First of all, about the complete layering of the interior of the earth, that the entire continental mass is made up of SEMA or Sial, that is silica and aluminum, and then the portion of the mantle, that is SEMA, the continental landmass ends up freely floating over it. So that was the assumption, which basically trickled down to various different incorrect reasoning as well. Okay. Abhishek, phenomena behind boiling water region present in Himachal Pradesh. That is basically when you have the water, the groundwater, through the various pipes and capillaries, when it gets into a passage and capillaries, when it gets in touch with very hot materials inside in the region of the mantle or the lower crust, sometimes even, that can give rise to these events of hot springs which are in existence. Vanshika, what is the landform in constructive plate margin? We have discussed that. You have mid-oceanic ridges, you have formation of islands in certain cases, you have formation of rift valley structures. All of these, they get created in constructive plate margin. Okay. Ilias, we are unable to see any boundary between oceanic plates. How we separate one plate from other? Are we able to see the boundary between the continental plates, Ilias? Absolutely not. Plate boundary is not something which is visually apparent, right? It is never something which can be seen with naked eyes. It is always understood with the help of the seismic waves itself, and detection of earthquake waves, we get an idea about what are the plate boundaries. And nowhere across the planet, regardless of whichever the plate boundary is, nowhere across the planet will you be able to figure out that this is the actual plate boundary of any particular region. That is not how it works. Yes, Yatindra, that is correct. And a kind of a uniform cooling, but also accordingly, you have a slow cooling process as well. Whenever there is an oceanic convergence, it will end up creating a oceanic trench. Always get that. Yes, Ashwant, you can send it. So, hello, a very warm good morning to all of you, and welcome to Baiju's Exam Prep IAS. Welcome to another session and another week of geography, where we shall be embarking upon the portion of geomorphology that is left behind. So, we have a couple of modules of geomorphology which are left. So, basically, last week we had talked about the continental drift theory, the theory of plate tectonics, seafloor spreading theory, and the convection current theory. Now, all these theories we have discussed in significantly greater detail, at least much greater detail as compared to what you find floating around in the materials, in the study materials that you have, or the reference books that you have. All that I would ask you to do is to try to consolidate it on your own, try to study it on your own, and try to understand it with the help of the world map on your own as well. That is going to benefit you quite significantly. But now that we have had some clue about the basics, about how the plate movement happens, why the plate movement happens, what basically are plates themselves, now we come to the portion of earthquakes, volcanoes, and then we shall be talking about the folds and faults as well. So, when we talk about earthquakes, volcanoes, folds, and faults, so what is it that is relevant for the prelims and what is it that is relevant for the mains exam? So, for the prelims, yeah, the basics of seismic waves, the basics of, or in this case, not the basics, actual questions from the concepts are asked. So, concept of shadow zone, then after that, types of magma, intrusive volcanic landform, also types of fold slash fault. These are basically the type of areas or the areas from where you can expect the occurrence of questions or questions can be asked from this particular region. Then, when we talk about the importance of this topic for the mains examination, generally in mains, UPSC has repeated a kind of a topic or a kind of a question from this area. And that is oftentimes something which has been repeated not only for the general studies but also for the optional paper. So that tells you UPSC doesn't have much of a scope in this particular region, which is a good news as well as a bad news. Why it is a good news is that you can have a kind of a prediction that what kind of questions, if asked, can be framed from this particular area. And the bad news for this is that every candidate will have the same expectation and will have the same prediction also. So when everybody is expecting a similar kind of question, everybody is preparing from the same material, that is a massive disadvantage. That means you will have to innovate significantly. You have to be creative enough and significantly smart enough to add on materials which makes your answer different. Otherwise, generic answers, all of them, they are given the same marks, regardless of with how much feeling we have written the answer, or regardless of how pure our mind was while we were writing the answer. If everybody has written similar kind of thing, everybody will get average to less than average marks. So that is where it is a good as well as bad news. So here, basically, you get questions about global distribution of earthquakes, also occurrence of volcanoes. So in that case, you get questions about hotspots, mantle plumes, induced earthquakes, and also distribution of volcanoes. So these are the areas where from where UPSC has been asking questions quite frequently in this topic. And the question which is framed, I'll tell you about that, and we will have a discussion about what kind of question can be framed and how to frame an answer about that. So we'll discuss about that. But before that, let us cover this topic of earthquakes, volcanoes, faults, and faults. Now, basically, before initiating the discussion about earthquakes and what earthquakes are, so whatever we have studied till now about the interior of the earth, the interior structuring and the layering of the planet. So whatever we have studied, we have basically studied that inside the planet, around the region of the core, you have significant amount of heat which has been trapped. And that heat has been trapped right since the time of formation of the planet. We have looked at that. And that heat is what we refer to as residual heat. Time and time again, that residual heat ends up getting released from the region of the outer core, from the region of the Gutenberg discontinuity that is between the core and the mantle, and it ends up reaching the surface invariably. Now, this heat which is produced from the inside, that brings about changes and impacts on the Earth's surface. It can bring about various different changes. It can lead to upliftment of land mass, the land sinking down, the land moving horizontally, and it can also bring about some sudden changes. Sudden changes, for example, can lead to the shaking of the Earth's surface that we will study in the form of earthquakes, or volcanic eruptions can also be initiated as a result of that. So all these events, they are initiated by the forces acting from the interior of the planet. So when we talk about the forces acting up from the interior, that is what is referred to as endogenic force. Endogenic forces. Now these endogenic forces, they are broadly classified into sudden forces. Sudden means they act all of a sudden, and they also sometimes act in a very slow manner. That is what is referred to as diastrophic forces. Slow acting forces. We'll read more about the classification of this in the next module. This is just to give you a preview that where is it that we place the conditions of earthquakes and volcanoes. So the forces acting from the interior of the planet, that is referred to as endogenic. Now, endogenic forces, that is the forces acting from interior, can have a sudden effect or can have a very slow effect, a very slow folding of the landmass, leading to the formation of mighty mountains, a very slow movement of the landmass creating a rift valley, a very slow movement of landmass creating a kind of certain structures or trenches, and so on. So Slow moving forces will have their own implications. But when we talk about the sudden forces, they are of two types: earthquakes and volcanoes. Okay, so that is what we are going to study, that how these forces from the interior, they end up creating earthquakes and volcanoes. But before that, let us understand what do we mean by earthquakes. So earthquake means what? Shaking of the earth's surface. Now, why will we experience the shaking of the earth's surface? That is because, as we have studied previously in the previous module as well, that whenever, let's say, the two regions of or two rocky areas, they try to move with respect to each other, the movement is not always going to be a smooth one. The movement in many of the cases is going to be absolutely haphazard, absolutely rugged, and in a manner non-regular kind of movement. So whenever these rocks, they tend to move against each other, so they end up releasing a lot of energy. Why? Imagine if, let's assume that you hold the fist of your hand, right? And look at the portion where you have the fingertips, right? Or rather the fingers and the indentions of the fingers. Hold the other set of fingers and try to move one with respect to other. Now you will observe that this movement is never going to be smooth. This movement is always going to be staggered and irregular. The other finger will offer a set of resistance to the first one. Eventually, as you apply pressure, as you apply force, eventually it overcomes that. And when it overcomes that, it tends to move suddenly. So there is a release of energy. So whenever you have two large pieces or masses of rocks, when they are trying to move with respect to each other, there is always going to be a force of resistance. So the energy keeps building up. Eventually, when that force of resistance is overcome, there is a sudden movement which happens, bringing about a large amount of energy being released. Now, that energy which is released, that shakes up the Earth's surface. And that is what we refer to as an earthquake, the shaking of the Earth's surface. Now, here, when we talk about earthquakes, these are massive, these are disastrous, and they spell disaster. The last time we had a major earthquake in India was basically on 26th of January 2001, when a massive earthquake that struck the region of Bhuj in Gujarat. Now, that earthquake was so strong that it had the shaking which was felt as far as Delhi in the north. Right? So that is how strong the earthquake was. So you have the occurrence of these massive earthquakes. The earthquake in Gujarat immediately flattened all the buildings in the region, and you had more than 20,000 people who lost their lives. That is not a small thing by any proportions. Then, similarly, in 2015, on 25th of April 2015, we again experienced a massive earthquake, which was centered around Kathmandu in Nepal. And that shook up the Earth's surface quite significantly. The impact could be felt all across the northern parts of the country. While Nepal was completely pulverized, buildings came crashing down. Many people lost their lives. Few people lost their lives in the plain region of India as well. So, such frequent or such massive earthquakes, they have been a frequent phenomena across the history of mankind. In fact, the early records, the early records which give us an enough idea about the occurrence of earthquakes. So they tell us that as far as around 1299 and 1290s, you had a massive earthquake which had occurred in the region of Kathmandu again. wiping out almost one third of the kingdom of Nepal at that point of time. So that is how massive and destructive it can be. In fact, the earthquake brings about the adjustment of the earth's crust in such a manner, because as the rocks are trying to move, these are very large rocks, very massive rocks, which are trying to move with respect to each other. Oftentimes what happens is that as that movement happens, it is not going to immediately come to a standstill. Maybe the rock adjusts after that in this new position. And that is where sometimes you will observe that the region where the earthquake has occurred, that has experienced a slight movement. For example, a few months back, you had a devastating earthquake in the region of Turkey and in the surrounding vicinity areas. Now, when that earthquake occurred, it was observed that the entire region of Turkey had moved ever so slightly. But the movement is not always only horizontal. Sometimes these adjustment of the rocks can break smaller pieces, and those smaller pieces can suddenly be propped up or thrown up. So imagine if this pen is a part of this rock, as the rock is sliding over the other, it might be possible that this pen as an adjustment be thrown upwards. So in the early 1800s, before the 1820s, you had massive earthquake again which occurred across the region of Gujarat. The earthquake was so massive that some area of the land in the sea that submerged, that went underwater. And simultaneously, you had an area of or a small portion of land which significantly was thrown up above water. It became a new island in that region. So that is where a massive adjustment tends to happen in terms of the crustal layer, in terms of the crust. And that is as the rocks try to adjust, as the rocks they try to move with respect to each other. That causes earthquakes. So whenever two pieces of rocks, let's say whenever you have two pieces of rocks which try to move with respect to each other, there is going to be a frictional resistance offered from some points. Let's suppose, if I give you an idea, let's suppose I have this layer of rock. Now, the rocky edge is not going to be the smooth one. It is going to be very rough, right? The other rocky edge is also going to be very rough. Now, let's suppose this is trying to move in this direction and this portion is trying to move in the other direction. Now, there will be a resistance offered by this protruded area of the rock that you find. There will be resistance offered there due to which the movement can get obstructed. Eventually, let's say slowly and steadily, the pressure, the energy keeps on building it up. And that is when eventually, let's say the motion finally happens. Now, when the motion finally happens, huge energy will be released from this particular point. And then that energy will travel in all directions and will end up hitting the Earth's surface, shaking up the Earth's surface. So, the point from which the energy of an earthquake is released underground, that point is referred to as the focus of the earthquake. Okay, so that is also the origin of the earthquake. So, when we talk about the focus, it is that point from where energy has been released underground. Now, depending upon the focus, based upon where the focus has been, sometimes you will come across the news stories that the focus is, let's say, 60 kilometers underneath the Earth's surface. Sometimes you will also come across the news story that focus is, let's say, 120 kilometers. In rare cases, you will also come across a news story that there was an earthquake occurring at a depth of 400 kilometers from the surface. We did not get to feel that because it had moderated by the time that it reached the surface. So based on the focus, you have a classification of earthquake into based on focus upon depth of focus. You can have the classification as shallow focus or shallow depth, then you have moderate. Shallow depth is generally the type of earthquake occurring up till around 60 kilometers from the surface, 70 kilometers from the surface, roughly till around 100 kilometers. That is considered to be a shallow depth focus earthquake. Then you will have intermediate focus. That is between 100 to 300 kilometers. At that depth, let's suppose at that depth there has been any amount of energy released due to the rubbing of the surfaces of the rocks with respect to each other, intermediate depth. And then we have the deep focus earthquakes. Deep focus. That is at a depth of 300 kilometer to 700 kilometer. These are what are regarded as the deep focus earthquakes. Every day, every passing day, planet Earth experiences hundreds of earthquakes every day. But we don't get to feel that. Many of them we are unable to experience because their magnitude or the energy released is very, very less. So you have various observatories and observing stations present across the globe, which keep a track of any of the slightest variations in the release of energy or any of the slightest shaking of the surface which ends up happening. So that is how we get to know that an earthquake has indeed occurred. But an earthquake ends up occurring many times every day across the planet. Now, here we do know that focus is at a depth. Focus is not present at the surface. It is present at a particular depth. Now, when it is present at a particular depth, and we have seen that based on depth, you have a classification. Classification, when we talk about the shallow depth, it comes for how much? Around roughly 0 to 100 kilometers depth. This comes out to be 100 to 300 kilometers. Now, how do we have a reference for where an earthquake has occurred just based on the focus? Let's say an earthquake has occurred in Gujarat at a depth of, let's say, 60 kilometers. If you have to refer to that, how will you refer it? Where in Gujarat has it occurred? You cannot simply say that 60 kilometers beneath the crustal layers at some region in Gujarat earthquake has occurred. No, you need a pinpointed location. So the point on the ground surface directly above the focus, that is what is referred to as the epicenter of the earthquake. Point on the ground surface directly above the focus, that is referred to as the epicenter. It is at the epicenter where the impact of earthquake is going to be maximum. So observe, this is the focus. The point above the focus, that is the epicenter. Okay, that is something which gives an idea about where an earthquake has ended up occurring. Okay, so basically that is the aspect of the earthquake in general. So here, shallow depth, I hope we understand the meaning of shallow, right? Any of us who don't understand the meaning of shallow? Shallow means not very deep. Okay, shallow means very close to the surface. Okay. No, Kishan, that is not lava. Okay. So, how do we measure the focus depth? We get an idea immediately about where the energy is released from by a multiple process of various observatories which are present across the globe. So, you will get to know that. Okay. So, here, basically, that is how the earthquake occurs. Again, I will quickly reiterate the point of or the source from where energy is released, that is referred to as the focus, and the portion on the land surface immediately above the focus where the impact is maximum, that is referred to as epicenter. Okay, so that is basically the focus and the epicenter. Now, when the earthquake occurs, there's a violent shaking of the earth's surface depending upon how much energy has been released. Many of the times, the ground surface ends up exhibiting a kind of a wave like behavior, a kind of a wave like pattern. And when that happens, when that wave like pattern happens, imagine if this is your hand, fair enough, you can end up waving it or bending it like a wave. But imagine if we have this as a solid surface, this pen as a solid surface. Now, if we start bending it significantly like a wave, what will happen? It will start breaking up. It will start breaking up. That is where many of the times large cracks they appear on the ground surface, very large cracks. In fact, in the case of few of the earthquakes which have occurred in the past, for example, when we talk about the earthquakes which have occurred, let's say the 1934 Bihar earthquake which occurred in the portion of northern Bihar. Now that was very unique in the sense that again it was close to 8 in terms of the magnitude of earthquake which we will study about it. But there, the consequence of it was there was large scale flooding in many areas of northern Bihar after that earthquake. Now, when you think about an earthquake, generally you do not end up associating it with floods. That why will floods occur if there is an earthquake? So, the reason behind it was so simple that wherever you had the ponds and the lakes, as the base of the ponds and the lakes they started shaking up, all the water was thrown outside. Moreover, as the ground surface started exhibiting a wave like pattern, large deep cracks developed in the ground, and groundwater started seeping out, started leaking out from many areas, flooding the entirety of the region. So understand that whenever that huge amount of energy is released, that huge amount of energy is going to end up shaking the surface to an extent that the surface might end up breaking quite significantly and immediately. So that is why earthquakes have always been an intriguing phenomenon that mankind has wanted to understand. But our level of understanding started increasing in the past century. That is around the 1900s. That is where we started studying the earthquakes, the energy released by the earthquakes. That is how we got to understand about it. Before that, we would basically classify earthquakes based upon what is the visual perception, that how much damage has been occurred or caused due to the earthquake. Okay, so that used to be the measure of it. If let's say an earthquake has occurred where nobody has felt it, so we would classify it as very light. If an earthquake has occurred and people have felt it but there are no buildings which have crashed down, so that is an earthquake of small intensity. An earthquake has occurred, destroyed and pulverized everything, every building has been reduced to the ground, earthquake of maximum intensity. So that is why when you come across the term of maximum intensity or moderate intensity or in general intensity of an earthquake, that used to be the earlier classification of the visual damage, right? So when we talk about intensity of an earthquake, intensity of an earthquake, it is basically what? It is The classification of the earthquake based upon the visual damage experienced on the ground surface. Visual damage experienced on the ground surface. That is the intensity. But this does not give you an idea about how strong or weak an earthquake was, because the damage on the ground surface can be dependent on many factors. For example, just to show you a kind of a variation in terms of how the damage on the ground can end up being very, very different, let me give you a certain set of examples. Suppose if I consider a region A, right? If I consider a region B, now in the case of region A, let's suppose there has been an earthquake which has occurred because of certain reasons of rocks moving against each other. There, let's suppose there's a convergence which has been happening, continental convergence, let's suppose. Now there, the earthquake has occurred at a depth of maybe 300 kilometers. Focus is at a depth of 300 kilometers. And in the other instance, at B, the same or the earthquake releasing same amount of energy that has occurred at a depth, let's say at 60 kilometers. The focus is at 60 kilometers. So in both these cases, we do know that basically the earthquake will have various different impact on the surface. Now both of them are releasing the same amount of energy, but one of them is releasing that energy at a depth of 300 kilometers. Another one is releasing that energy at a depth of only around 50 to 60 kilometers. So where do you think the damage will be more? Always in the case of B, where the energy is released much closer to the surface. So the damage will be much significantly more in the case of B. So here, we cannot have the proper classification. Maybe the energy released here is slightly more, but the visual damage is less. So we won't have to be able to do justice to the intensity of an earthquake. Also, take the case where let's suppose we have a condition. Let's suppose in this condition, both these regions have an equal depth of 60 kilometers where the earthquake has been occurring. Or let's assume it is 100 kilometers. Let's assume in both the cases. Now, in one case, let's suppose in the case of A, we can have a complete large rock slab like we observe in the plateau regions. For example, in the southern part of India, we have very hard rocks which are present, igneous rocks, very large scale igneous rocks which are present. So let's suppose you have a very such large igneous rock slab, but there is an earthquake which has occurred at a depth of around 100 kilometers. On the other hand, in the case of B, let's suppose you have sedimentary soil, no rocks in that case, or not major predominance of rocks. On top of the surface, you have, let's say, we consider the northern part of India, the plain region of India, where you have 2 kilometer, 3 kilometer deep sedimentary soil in certain areas. Now, in both these cases, even if same energy is released, if let's say this is made up of rocks, large stable rocks, and this is, let's say, made up of sedimentary soil deposit, Now, in both these cases, if the earthquake of same amount of energy occurs, the amount of damage on the surface, is it going to be same? Is it going to be different? It is going to be very different. Here in this case, when you have the earthquake which occurs in the region of A will shake up, right? A will end up shaking up. A will end up facing a disturbance. But when we have the same occurrence on a sedimentary soil, in a sedimentary soil region, the entire region will end up exhibiting a kind of a wave like pattern. Any building, any construction which, let's say, is prevalent there, the amount of shaking will end up reducing everything to the ground surface. That is why an earthquake of 8 magnitude which occurred or when occurred across the region of northern plains of Bihar, the entire region was pulverized. Imagine this occurred in 1934. We all know about the state of infrastructure which is present in the eastern part of the country. We know that the state of infrastructure in Bihar is not good. Imagine what the state of infrastructure would have been going back in 1934. Still that earthquake. So in 1934, you would not have had two-story buildings, three-story buildings. That would not be predominant across the northern parts of Bihar. But still more than around 10,000 people perished because of that earthquake. So that is why when these earthquakes, they end up occurring over a plain region, devastation is more. So the amount of damage on the surface, that will be dependent on how deep the focus is. That will be dependent upon what kind of surface is. Now let's suppose the same intensity earthquake occurs in the region of, or the same amount of energy of earthquake occurs in the region of Japan and that of, let's say, New Delhi. Now, in the region of Tokyo, for many decades now, any building which is being constructed is earthquake proof or earthquake resilient. They can experience and withstand some amount of shaking. But we cannot say the same for New Delhi. So, if the earthquake occurs, the same earthquake releasing same amount of energy occurs in both the places, destruction will always be more, visual destruction will always be more in New Delhi. So by just taking a look at the intensity of an earthquake, we will never get an idea that what is the overall amount of energy released. So in order to measure the energy that is released, we use an instrument. Instrument is what is seismograph. Seismograph. Now this seismograph is very similar to that of an ECG machine that you see, where you have a roll of paper which comes out and there is a pen which keeps on moving with respect to that seismograph. So oftentimes the depiction that you get in the case of a seismograph will be somewhat like this. The depiction that you get on a seismograph. Now this measures slightest amount of shaking. Okay. Slightest amount of shaking, they are also measured by this seismograph. So this is used to measure the energy which is released, the amount of energy which is released by looking at this measuring on the graph. So here, the greater the amount of energy released, greater will be the movement of that pen. So here, when the pen ends up moving like this, you get to know that an earthquake has occurred. Even if, let's suppose, you are not in that area, you are somewhere else, your observatory might be in a Pacific Ocean, you might end up measuring the earthquake which has occurred in Nepal also. So here, in this case, how do we get to know about the energy released? So we end up measuring the amplitude. The amplitude that is measured. So that gives us an idea about the magnitude of an earthquake. So when we talk about the magnitude of an earthquake, it depicts the amount of energy released during an earthquake. Okay, amount of energy released during an earthquake. So this is measured on a scale which is referred to as the Richter scale. So measured on Richter scale. Richter scale. And this Richter scale is logarithmic in nature. It follows the kind of a log rule, if you can say like that, loosely place it like that. So that means, let's say an earthquake of magnitude 6 has occurred, and in other place an earthquake of magnitude 7 has occurred. So 7 magnitude earthquake will end up being 10 times stronger, releasing 10 times more energy as compared to the magnitude 6. An earthquake of magnitude 8 will end up releasing 10 times more energy as compared to the magnitude 7. So that is how it is a logarithmic scale. When we talk about the intensity of an earthquake, this is measured based upon the visual perception of the damage that we have. So accordingly, it is classified and it is delineated with the help of what we refer to as Mercalli scale. Mercalli scale. It has got its classifications. For example, intensity of 1 on Mercalli scale means it has not been felt by individuals. That is how light it was. A scale of, let's say, 12 on Mercalli scale means that there is complete devastation. Everything has been destroyed in the process. So that is basically how you have the classification. Now here, what you observe as a graph, as an image created by seismograph, this gives us an idea about how the earthquake has occurred and what are the details. So, for example, when you observe this particular region, or let's say when you observe this kind of a reading on seismograph, what does it tell you? That before the main event, when there has been significant amount of shaking, before the main event, we have conditions where there is shaking before. The rocks, they start to move, and when they finally move, that is when majority of the energy is released. But before that also rocks have been adjusting. So these are the earthquakes, or these are slight shakings which are experienced before the main earthquake. So many of the times it happens that when the main earthquake occurs, before that itself, maybe a month ago, maybe a week before, maybe a couple of days before the main earthquake, or maybe even a few hours before the main earthquake, there's a slight shaking which happens. These are referred to as foreshocks. Foreshocks. And then after the main earthquake again, there is significant amount of shaking sometimes experienced. For example, when the Nepal earthquake happened in 2015, there was a shaking of the surface for many, many days and even many weeks and a couple of months after that earthquake as the rocks were adjusting to the new position. So, even after the main earthquake has occurred, there are chances of again a kind of an adjustment, a shaking of the earth's surface being recorded. That is what is referred to as aftershocks. Aftershocks. Sometimes aftershocks can extend for even few months, couple of months, 3 months, 4 months. Foreshocks can also extend for many days prior to the earthquake. Okay, so that is something, the how we end up measuring this particular earthquake. So here you will observe that there are two scales which are generally used in terms of the classification. Mercalli scale represents the intensity of an earthquake, whereas Richter scale, it represents what is the magnitude of the earthquake. And how do we get to know the magnitude? Magnitude we get to know by seismograph. It measures the amplitude of energy released during an earthquake. So here, the range or the classification of Mercury scale based upon the visual damage which has occurred can be up till 12. 12 indicating that everything has been destroyed. Nothing is left on the ground surface. One being, it has not even been felt by the individuals on the ground surface. That is how light it was. And here the magnitude is 1 to 10, but beyond 9, it is rarely experienced. Even the earthquake which occurred in Bhuj in Gujarat, which caused so much amount of destruction and devastation, everything was pulverized. Now, even that was around 7.9. You have had massive such earthquakes occurring all around the world. So, here, this magnitude or the Richter scale is basically logarithmic in nature. In nature. Okay, so that means an earthquake of magnitude 7 is 10 times more powerful as compared to earthquake with magnitude 6. Okay, so that is basically about the aspect of intensity and magnitude. So overall, a brief definition of magnitude. So amount of energy released by an earthquake is called its magnitude, can be measured by the amplitude of the seismic waves which are produced. So here, whenever an earthquake occurs, it releases energy, and that energy will travel. Any energy travels. When we say, when we speak, we emit sound energy, and sound energy travels. When you switch on the light or when the sun rises, light energy travels. So when energy ends up traveling, they end up moving in the form of waves, right? They end up moving in waves. So similarly, when we have, let's suppose, when we consider the planet, now let's suppose an earthquake has occurred somewhere here. Somewhere here. The focus is somewhere here. Let's suppose. Now, because there is a release of energy, that energy will end up getting released in all direction. Energy does not know any direction. Unless and until you provide a direction, energy moves in all direction. So from here also, energy will be released in all different directions. Energy will be released in this direction also. Energy will be released in this direction also. Energy will be released in this direction also. It will be released here also, here also, here also. So, release of energy basically is multi-directional. The release of energy happens in all directions. Now, the region which will experience it first is the region immediately perpendicular or above the focus. And that region is referred to as what? That region is the epicenter. Okay? That region is what is referred to as the epicenter. So that is what we have in the case of earthquakes, the basics of it. Okay? Any doubts that we have till now? Do we have classification of earthquakes based on magnitude? So based on magnitude, you have very high energy earthquakes, moderate energy in earthquakes, etc. But that is not a very well used classification. Foreshocks can be used for predicting earthquakes. See, not always, because in many of the cases, these foreshocks, they can exist for a very long time. For example, take the case of Palghar in Maharashtra. Now, Palghar in Maharashtra has been experiencing slight shaking for multiple months and a couple of years now, but there is no major earthquake to be followed. So that is where foreshocks can oftentimes be misleading that when an earthquake will occur. Logarithmic, basically, when we say logarithmic scale, so when we have a kind of the scale that you end up using, that scale when we use, so it is very linear in the sense, right? 1 2 3 4 5 6. I am sure that till our class 10th level we would have let's suppose we have no clue what is logarithmic. So in order to depict the amount of energy ends up increasing exponentially beyond a point. And that is where to depict it, you require a logarithmic scale. The amount of energy released is not linear, it increases exponentially. So that is why to depict it, we do need a logarithmic scale, which gives us an idea about the depiction on terms of Mercalli scale. Okay. And Vivek, condition in case of sandy soil, whenever you have a lot of sandy soil or whenever you have a very thick kind of deposition of soil, there will be a lot of damage. Lakshmi, but sir, you said energy is measured by seismograph, but what after but? Yes, energy is measured with the help of the seismograph. Okay, energy is measured, the amount of energy is measured on that Richter scale. The seismograph will paint you a kind of an idea about, just like an ECG machine, it will be generated. Okay, so that is where you have an idea about the magnitude. Jyoti, earthquake occur in which type of boundaries? In all type of plate boundaries, earthquakes will occur. All type of plate boundaries. Don't worry, I'll give you the entire summarization of this after we complete the portion of earthquakes. I have a question by Preeti. Can foreshocks and aftershocks also be experienced by people? Yes, obviously, yes. Otherwise, in many of the cases, you will find that after a massive earthquake, many people they face that kind of a trauma where they get so used to facing that foreshocks and aftershocks that even when there is no shaking, they will have a kind of idea that the ground is shaking or there's an earthquake happening. And it might seem to be something funny, but please understand that whenever in any area a massive earthquake has occurred, people in that region have suffered from this kind of a traumatic stress for multiple months and years together. So that is where they keep on experiencing these uh, aftershocks and foreshocks, and that becomes a habit which the mind inculcates later on. Yeah, a kind of a PTSD. Soumya, after we complete the portion of earthquake, I'll give you a summarization. Can there be more than one epicenter? Absolutely never, Shashank. How can we identify the perpendicular direction of focus? There will be only one perpendicular direction, won't it be, my dear friend? It will be leading to the surface. From this region to the surface, can we have multiple perpendicular directions? Never. Just because I'm showing it in a sphere, and that is the same logic that if we stand in Antarctica, we will fall from the earth. If we stand here, we will fall from the earth. Don't look at it as a sphere that it will have multiple perpendiculars. Suppose here there is a ground surface. If let's say the focus occurs here, how many perpendiculars can you draw from here to the ground surface? There will be only one perpendicular, isn't it? There will be only one perpendicular. So epicenter is always going to be one. Okay. Mercalli scale puja is the scale which is used for measuring the visual damage which has been caused by an earthquake. So you have classification as one, has not been felt, two, trees have shaken slightly, trees have moved, and three or four, let's say the buildings have moved ever so slightly, five, significantly felt by everyone, 12, maximum catastrophic destruction or devastation. Okay. Anjali, that is correct. Femina, if so, epicenter is the ending point of inducing energy from the focus point. Sort of, but after that, also a lot of energy is generated in the process. Do we need to understand about logarithmic more for the exam point of view? Absolutely not. Please don't start digging into the portion of logarithmic scale. What are logarithmic scales and log tables? Don't do that. Whatever we have studied till now, more than sufficient, right? If a question is asked from this area, can't we predict an earthquake? We don't have an exact prediction model for an earthquake. No. Uh, then I have the same question by other people as well. Chile, you also have the same question. How many times aftershock occurs? Pravasini, multiple times. There is no fixed case. Sometimes no aftershocks can occur. Okay, right? Has a moment magnitude scale represented by, so magnitude is represented by Richter scale, Amrit, and Lakshmi, if you are getting confused between a Richter scale and a Mercalli scale, forget seismograph for a moment. Don't think about seismograph. Just understand that you have two scales of measurement. One is what is used to measure the intensity based upon the visual destruction. Other is what is used to measure the amount of energy released. One is the Mercalli scale, other is the Richter scale. Is that understood, or is there a confusion in that as well? Forget about what seismograph contains, how the seismograph looks like. Nobody is concerned about that. Think about what is Mercalli scale, what it measures, what is Richter scale, what it measures. If that is understood, the job is done. Okay. Yes, Raghav, it won't affect, depth doesn't affect the magnitude. Eventually, you will have multiple different observatories all across the planet, which will end up measuring the energy released. And eventually, you get an idea about how much energy had been released from this point. So, that is what is depicted as magnitude. Magnitude is not what is the energy experienced on the ground surface, it is a measure of how much energy has been released from where it has been released. So you have computer simulation models that if at this depth, or if this much shaking has happened at this depth, what would be the energy release that has released to, or that has caused that much shaking on the surface. Okay. Does the intensity of waves traveling in different kinds of landform differs? Yes. Depiction of earthquake location by using world map. Answer yes. Uh, Foreshocks and aftershocks. Basically, when the rocks finally end up moving, before that also there will be ever so slight an adjustment. So that adjustment will also end up releasing some energy periodically. That has occurred before an earthquake, hence foreshock. And after the main movement has occurred, even after that, let's suppose the rocks are again getting adjusted, that is an aftershock. Ravindra, yes. The breaking of surface occurs during an earthquakes. Pulkit, I have explained aftershocks. Can it happen that epicenter is in one place and earthquake is another place? Why? Why will that happen? Epicenter is where the earthquake occurs, right? So it is akin to asking that if I tell you about rainfall, it is akin to asking that this region is getting wet. Can it be possible that rainfall has occurred somewhere else? Why? It will occur there. That is why that region has been wet, isn't it? What is the use of amplitude when the earthquake is measured by a seismograph? Okay, that means we don't have an idea about amplitude. Fair enough. So when we talk about, let's say, the measurement of an energy wave, so when high amount of energy is released, there will be a variation like this. When low amount of energy is released, there will be a variation like this. This measurement, this is the amplitude. This is the amplitude. So it is by this that we get an idea about how much shaking has happened. Okay, I hope that is understood. I heard that earthquake with magnitude 6.5 or less will not cause damage. Is it true? Please clarify. Okay, are you facing a danger of an earthquake? I love it when the questions are so demanding in that sense. Please clarify immediately. Otherwise, the matters will escalate. Okay. So please, first of all, don't go by hearsay that what you have heard, what you have seen on the social media. It depends on the type of surface. It depends on the depth. Sometimes an earthquake of magnitude 5 can end up causing a lot of damage. The earthquake which happened in Latur in Maharashtra was less than 6.5 in magnitude. The amount of damage it caused led to the death of more than 5,000 people there. Sometimes you can have a magnitude of 6 and no damage can be occurred because of that. So it is very, very different. Okay. So Srinivasan, have we understood that earthquake and amplitude aspect of it? Okay. And guys, please don't paste the same question again and again. If you have pasted a question, hold on for a moment. I will come to it. What is happening is that you have been putting the same question and again and again. It is almost impossible to take the other questions also. Okay, so if you have posted a question, fair enough. If possible, I'll take it, or the SMEs will end up taking it. Mercalli measures intensity, Richter measures the magnitude of earthquake. Yes, my dear friend, that is again correct. Japan is having a technology to predict earthquake. Okay, we'll come to that. Why Mercalli? Because you had Giuseppe Mercalli who came upon with this classification of a scale, hence the name Mercalli scale. Pravasini, yes, it can occur for months. If the epicenter is on the island like Sumatra, why we had tsunami? Okay, my question to you guys is, did you have problem in the portions that we have covered till now? And that is the problem that I am addressing. Okay, not the problem that I have heard from somewhere that this earthquake, when it occurs, the gods come down to the earth. Not the fact that if this occurs on Indonesia, what happens in Japan. We will cover all of them. This is not the completion of earthquake. Okay, not the problems that how is it that the seismic waves travel. We have not even talked about it. My question was very simple: the problems or the issues faced till now, not the issues that you have been facing in your life till now. So wait for it. We will come to it. Have patience. We will cover each and every point of it. Okay. And again, the same question is being repeated. So I'll not be the one who will take your names just for the sake of it. So the same question which is being repeated multiple times is difference between intensity and magnitude. I have written the difference here. Intensity is the classification of earthquake based upon the visual damage. Magnitude is the measure of the amount of energy released during an earthquake. Now, amount of energy released and the damage caused can be very, very different depending upon the type of surface, the depth at which the earthquake has occurred, and so on. Now, this is measured on a base of a list of scale of classification, that is Mercalli scale, and this is measured based upon the amount of energy released represented on a chart by a Richter scale. That is the only portion that we have covered. Okay, please wait for some time before getting into the aspect of why in Indonesia tsunami has occurred. Does Japan have a prediction model? Does Japan use sandbox technique? We have never even come to that till now. Wait for some time, we will come ahead. Okay, right? Monica, what is your question? See, I have taken so many questions, and still, I am sure at the end of the day, I will have so many complaints that my questions were not taken. Do earthquakes reflected back? No, absolutely not. Majority we use Mercalli or Richter scale. My dear friend, Mercalli scale is used for a different classification. Richter scale is used for a very different classification. Richter scale is used to measure the energy released. Mercalli scale is used to measure the visual damage which is caused. Okay. If earthquake occurs on two different places, then how many will be the epicenter? Wherever the earthquake has occurred, immediately perpendicular to the ground surface, you have the presence of an epicenter. Wherever the earthquake has occurred above the ground surface, there will be epicenter. Okay. Shallow seismograph used both Richter. Okay. I think this is the sentence which is confusing everyone. Forget this sentence. Okay. Don't think about this sentence. Think about what is Richter scale, think about what is Mercalli scale, and then move on. Even your life will not be different if you get confused by this sentence itself. Kosor earthquake in Turkey caused in Gaziantep, caused by moving of Anatolian plate moving west, Arabian plate moving north. Do we have to remember the map pointing regarding to this? You have already remembered the map pointing regarding to this, but this will never be asked in the exam. That which plate was moving, show it on the map. That will never be asked in the examination. The pattern of question is very, very different. If underground material consists of soil in abundance, will earthquake energy be absorbed or exaggerated? It will be exaggerated. Uh, okay. And Monica, your questions have also been answered now. Kausar, your question has been answered. Chile, at which point on Richter scale can we make earthquake is very high? Anything above 5 is considered to be serious. Anything above 7 is considered to be devastating. Anything above 8 is catastrophic. Nobody will be, or nothing will be left as it is. Every building will be lost in that region. In ocean, transform faults are planes of separation, generally perpendicular to the mid-oceanic ridges. Yes, they are true. So, Nisha, where energy is released is also called as hypocenter. Yes, thank you for the information. There can be multiple epicenter and focus points in one place. For every earthquake, there will be only one focus where the energy has been released. That is referred to as focus. There can be other earthquake which can happen right next to it. It will have a different focus. There can be another earthquake happening right next to it. If the rock is, let's say, moving like this, if the crust is moving like this, there can be an earthquake here, there can be a resistance here, there can be a resistance here. But simultaneously, not from everywhere energy will be released, right? Energy will be released either from here or from here, ending up shaking the surface. Okay. Richter scale measures what? Hmm. So we have been studying about earthquakes. We have been studying about the measurement of how we classify the earthquakes. So when the earthquakes occur, energy is released. That energy ends up shaking the ground surface. So that measure of energy is done with the help of Richter scale. And this earthquake will cause visible damage on the ground surface, and that is measured with the help of Mercalli scale. Can we move ahead, or do we have a perception that only Richter and Mercalli will be asked in the exam? Okay. Does the aftershocks intensify be higher if the intensity of earthquake was higher? No, it doesn't work like that. What are the possible questions on Turkey earthquake? Zero questions. Zero questions. UPSC never asks you questions like that. If an earthquake has occurred in Turkey, do you think UPSC will frame a question that where has the earthquake occurred? Delhi, Mumbai, Bangalore, or Turkey? No. Do you think UPSC will ask you a question that explain the earthquake in Turkey? Never. UPSC will ask you about the basic of an earthquake. Why an earthquake occurs? Give the reasons for the movement of an earthquake, right? Give the reasons for the plate movement. That kind of questions UPSC will ask. Now we move ahead and we come to the portion of seismic waves. Now, what do we understand by seismic waves? So whenever an earthquake occurs, that earthquake ends up releasing energy. That energy ends up traveling through the entire body of the earth's surface and even on the surface itself. And these energy waves, they are referred to as seismic waves, right? So here, when an earthquake occurs, it releases waves of energy which are referred to as seismic waves. Now, there are two types of waves, energy waves. When you measure seismic waves, there are two types of these seismic waves based upon where they are in existence. So, try to understand this. In mains examination for general studies, no map based question is asked, Chetna. So be very clear. For general studies, no map pointing for the mains. So here, let's say an earthquake has occurred somewhere here. Now the energy waves will be transmitted in all different directions. Right? Now, let's consider this particular portion. Let's draw out this particular portion, the epicenter region. Now, when we draw out the region of epicenter, here the energy waves, first of all, will reach where the epicenter that is going to be closest. It is perpendicular. So epicenter is going to be closest to the focus. So energy waves will reach there first. Now, understand some aspect. So here, as the energy waves, let's suppose this is the ground surface. As the energy waves, they will hit the ground surface. That ground surface will get disturbed because it is not like an individual block of mass which will move up and down and then it will settle down. No. If let's say This is the region of the epicenter. If let's say here there is a kind of a variation, there will be a variation experienced all around. If there is an impact here, so this will vary, this will have a wave like motion, that will have a wave like motion, and the entire surface will end up generating a wave like pattern. So that is where we have the basic classification of seismic waves. When we talk about seismic waves, here, these seismic waves, they will travel through the body of the earth. And when they hit, let's say, the epicenter, after that, the surface starts to get impacted. The seismic waves have come from inside, they have hit it. After that, the surface generates a new wave on its own, which spreads all around, just like what you observe as ripples in water. They end up spreading all around on the surface. So from here, a new set of waves will be generated on the surface, which will spread all around the epicenter. So the further away that we are from epicenter, the impact will slightly start reducing. If let's say an earthquake has occurred in Kathmandu in Nepal, epicenter at Kathmandu, if let's say you are very next to it in Janakpur or maybe Pokhara, etc., the destruction, the damage will be very high. If you are in Jaisalmer in Rajasthan, you will not even feel that, right? Because that shaking of the surface will not even be able to reach you. So when we classify the seismic waves, we now have two types of waves. One type of wave which has traveled through the body of the planet, which has hit the epicenter first. Now, because it has traveled through the body of the planet, that is why they are referred to as body waves. Then, once these body waves, they will hit the epicenter, they will disturb the epicenter and the ground surface. So the ground surface ends up representing or generating a kind of a wave-like pattern as well. That is the wave generated on the surface, movement on the surface. So that is what is referred to as surface wave. So when we talk about body waves, here, energy waves or seismic waves, which travel through the body of Earth. When the energy hits the surface, surface generates waves which spreads from epicenter to the outside. To the outside. That is what is referred to as surface wave. Now, when you talk about the classification of these, now body waves basically they end up traveling through the body, released from focus, right? So the source of these body waves is from the focus. The surface waves will be moving outside from the region of epicenter, isn't it? Now, there are multiple different types of body waves. You have P, S, P star S, S star G, PG, PR, S star R, and so on. Many of these different types of body waves are in existence. But then, for your general studies, thankfully, you only have to be aware of two types of body waves, that is P waves and S waves. Okay, so we'll familiarize ourselves with these body waves first, and then we'll take a look at what these surface waves are. Okay, so here when we talk about it, for example, when we talk about seismic waves in general, let's start with the aspect of body waves. Body waves, why? They travel through the body of the planet. Okay, I have written it earlier also, so I hope that should suffice. Now, body waves are of two types. You have P waves and you also have S waves. Okay, P waves and S waves. What are these? So, when we talk about P waves, by the way, let me also write, both of them will be released simultaneously whenever there is an occurrence of earthquake. Now, the classification is based upon how they end up traveling. Both of them will be released from focus at the same time. And basically, how will they travel in terms of how is it that the particles are disturbed? That is why the classification is done. Don't think about it that one earthquake will release only P wave and an earthquake which occurs on Saturdays will release only S waves. No. Any earthquake which occurs, simultaneously they will release both P and S waves. So let me write it down. Simultaneously released from focus during an earthquake. Which wave is more destructive? Surface waves are destructive. Body waves, they don't carry much destruction. So here, let us take a look at this. P waves, or what are also referred to as primary waves. Primary waves. Now, when we say primary waves, so let's imagine that you have in the interior of the planet, when we talk about, let's say, an earthquake which has occurred at 100 kilometers depth. So there, the material will be in a solid state. In solid state, the molecules are attached to each other, very closely bonded, very closely spaced. Now here, let's suppose we talk about the molecules in that solid state. Now, in this case, let us assume focus is here. Okay. And the direction of energy propagation is like this. Now, here, please don't get confused that you had said that epicenter is up. Now you are saying it is on the right. I'm just trying to depict here. It can very well be depicted even in the case of vertical aspect. So before anybody gets confused that does the wave only move horizontally, will the epicenter be somewhere in the horizontal? Let me clarify. No, this can be very well depicted in a vertical manner as well. Just to give you an idea about how the wave travels, that is why I've taken this kind of a creative liberty, if you can call it so. So here, when we talk about the focus, that is where the energy is released. Let's suppose this is the direction of wave movement. Wave movement. Now, as the energy is released, here, first of all, what happens is that the first particle gets disturbed in this direction. That is in the same direction as the movement of energy. Now, when the first particle gets disturbed, it enters into the space of the second particle. So the second particle will again get disturbed. The third particle will also get disturbed. The fourth particle will also get disturbed. All of them will start having a kind of an oscillation, a kind of a motion. So all of them will end up inculcating a kind of a motion. So what will it appear like? So here, the propagation of wave will appear in the form of compression and rarefaction or expansion. So the waves will move in a method where they get compressed, the particles get compressed, rarefied, compressed, rarefied. Again, after some time, this will get rarefied, this portion will get compressed, then other portion will get rarefied, the other portion will get compressed, other portion will get rarefied. So that is how, by compression and expansion, that is something by which this can travel. Okay, so that is how the wave ends up traveling. Now in this situation, the direction of wave motion and the direction of particle disturbance, that is the same. It is absolutely the same. So when we have the direction of wave motion and the direction of particle disturbance being the same, the wave ends up traveling at a much faster pace. It ends up traveling at a much faster pace. So here, direction, that brings us to the first conclusion. Direction of wave motion is same or similar to direction of particle movement. Hence, the movement of the wave or the propagation of the wave is going to be much faster. Hence, propagation of the wave is much faster. It ends up traveling at a much faster pace. Then, let's say the particles are a bit away from each other. Let's suppose we consider solid medium or a liquid medium for that matter. Let's suppose we consider liquid. So when we consider a liquid medium, in that situation, what do you experience? The particles are slightly far away from each other. They are slightly far away from each other. So in that case, if the energy is released from here, that means there will be a vibration. Still, despite the fact that the particles are far away from each other, they will go ahead and disturb the other particle. They will go ahead and disturb the next particle. They will go ahead and disturb the next particle. It will always happen. So when the particles are far away from each other, in that case, the first particle, when it moves and comes back, there will be some disturbance in the second particle, and that is how propagation will happen. But here, let me ask you a question. The question is that when we talk about different state of matter, solid, liquid, and gas, we are aware that the molecules, their distance is very different. In which of these cases do you think the wave will travel the fastest? Solid, liquid, or gas? Majority of you are correct. That is the solid. Few of us, we tend to apply a lot of logic, so we might get incorrect. Why not using animation? Byju's already have so many animations. Very nice. So, what do you think? The smarter people, why do you think we are not using animations? You would have some reason also. Are you understanding the concept taught or not? Leave animations, leave the images. Are you understanding the concept that we have talked or not? Okay. So here, basically, it will travel the fastest in the case of a solid. And the reason most of you have given correctly, and the reason all of you have said correctly, that in the solid, the particles, they are very much attached to each other. So a slightest movement in the first particle will inevitably end up impacting the second particle. So we can come to our second conclusion with that. The first conclusion that we had was that because the P waves, in that case of P waves, the materials, the particles, and the wave propagation is happening in the same direction, the wave movement is going to be the fastest in the P waves. Second conclusion we can make is that despite the P waves being able to travel in solid, liquid, and gas, here the speed will be fastest if the density is high. So that means, let's suppose I give you now a slight variation of the same question that I asked you. I give you a slight variation. Apply your logic and get back to me with an answer. The question is that if I ask you about two different places in the interior, one is the semi-molten asthenosphere, other is the core, the inner core. Out of these two places, where do you think the seismic waves will be able to travel faster in the case of P waves? Where do you think? Asthenosphere or inner core? Beautiful. That is because inner core is in a very condensed solid state. So that is why it will always be able to travel at a much faster pace in the region of inner core. So let us write our second conclusion in that case. So P waves can travel through solids, liquids, even gases. Right? Now, here also, in case you don't have a doubt, the only reason that the P wave and S waves, they are able to, or rather, in case the of P waves, when we consider, the only reason they are able to travel through solid, liquid, and gas is because of the reason that in the case of the P waves, the energy of the particle movement is in the same direction as the total energy propagation. So the particles will end up having a disturbance on the next one invariably, regardless of the particle distance. So that is why it can travel through solid, liquid, and gas. Okay? Here, speed is directly proportional with the density, okay, of material. Greater the density, greater will be the speed. Lower the density, slower will be the speed. Okay? Now, when we talk about the S waves here, the secondary waves. So, when we talk about the S waves or the secondary waves, Now, these are also released at the same time. At the same time, from the same place, that is the focus, they are released. But they end up influencing the direction of the particle movement in a different manner. How? Let us understand that. Suppose here you have the various particles in a solid closer to each other, which are attached with each other with a kind of a solids have a very strong bond, isn't it? Now let's suppose there is a focus here. This is the focus. This is your direction of wave movement, of energy movement or wave movement. Now, in this case, what will happen is, as that energy is released, the particles, rather than oscillating in a manner which is going to hit the other one, they will end up moving like this. Now, the first particle will start moving almost perpendicular because of the energy released. Now, when the first particle moves up, it will drag the second particle also. That will drag the third particle also. That will drag the fourth particle also. That will drag the fifth particle also. So, how will the energy end up transmitting? It will give you a kind of what a typical wave looks like. So, the motion associated will be like a sine wave or sinusoidal wave. Now, in this case, the particles, they are moving in a almost perpendicular direction as compared to the direction of wave movement. So the time it will take for this wave to reach the surface, that is going to be lesser. Okay, let me repeat this entire process. So in the case of S waves, when you have these particles which are bonded with each other, here the movement is transverse. Here the movement is different as compared to the direction of the wave propagation. So as the first particle, let's say, moves here, first particle moves here, second particle will be dragged somewhat, and that is how the entire wave motion will be resulted into. That is how the entire wave motion will be resulted. Right? So that is where you observe that the direction of particle movement is different from the direction of wave propagation. So that means the speed by which the wave will be able to travel, that speed will be lesser. So here, direction of wave motion, just like how light waves travel. Light waves also travel in the same manner. When you depict the light waves, you also depict the same sinusoidal manner. Here also, S waves travel in the same manner. Direction of wave motion is perpendicular to the direction of particle movement. Okay? So as a result of this, propagation or the speed of the wave is much slower. Okay? It has got a much slower speed. Now thinking about other situation, let us consider a liquid in this case, just as we considered it earlier. Now when you consider a liquid, the particles are very far away from each other. Now, let's suppose the first particle gets disturbed. Second particle, not very much getting disturbed, right? That particle is not getting into second particle space. So let's say the amount of disturbance is lesser. The third particle, it has got nothing to do with that disturbance, right? So even lesser variation. And eventually, by the time that you reach the fourth or the fifth particle, the impact dies down. Why? In the earlier case, it was present. In the case of P waves, that was present. Because in the case of P waves, each and every molecule and particle was hitting the next one and entering into the other space. That is where the disturbance carried out. Right? Here, the disturbance is limited. So that brings us to the second conclusion, that in the case of liquids and gases, when the density is very less, S waves, they are unable to travel. So S waves are unable to travel through solids, or rather liquids or liquid and gaseous mediums. Now, in this entire process, we have seen that P waves and S waves, they have been released simultaneously from focus. P waves travel faster, S waves travel slower. So which will reach the surface first? The P waves, they travel faster. So this is a property of seismic waves. P waves generally are around 1.7 times faster in comparison to S waves. So they end up reaching the surface first in general. And the S waves, along with the main impact, basically, that reaches the surface sometimes 2 minutes later, sometimes 30 seconds later, sometimes 1 minute later. But there is a time gap. And this time gap is utilized to save lives. Because all the early warning systems that you have, the early warning systems of earthquakes that you have, they deploy the P wave detection model, that you develop an equipment or a device which will be able to detect even the slightest of the P waves released. And how will you be able to distinguish the P wave and the S wave? Depending upon the particle motion near the ground surface. Now, earlier, when we talk about the region of Japan, Japan would be frequented with very high magnitude earthquakes. Very high magnitude earthquakes causing a lot of destruction, a lot of devastation. And Japan, India is still contemplating whether we bring high speed rail or not. But Japan had brought the high speed rail network in the 60s itself. The bullet train started getting developed in the 60s itself. Now, during the 70s and 80s, and even during the early 90s, you had a couple of incidences where a massive earthquake struck, and these fast moving bullet trains, they were simply thrown off the rails. Imagine you have a fast moving bullet train and the ground starts shaking underneath. Everything will be thrown away. So the bullet trains were thrown away. Now that brought about a lot of destruction. The bullet train actually crashed into a nearby building and many people lost their lives. Now, you will never or never hear about such kind of stories repeating themselves. Why? Because now they have installed this P wave detection system, detection model, where when you have the P waves which are felt, immediately an alarm goes off across major public areas, across the rail network, etc. The alarm goes off. Now, as soon as the alarm goes off, emergency brakes are applied across all these fast moving bullet trains. Within 25 to 30 seconds, wherever they are, they come to a grinding halt immediately. And that means that when the main earthquake strikes, along with the full power of S waves, there you have the trains in a static position. At least they are not moving fast. So that is how limitation has or damage has been limited. There is this damage limitation. Now you might think that 1 minute, 2 minute time window, what is it? 1 minute time window, 2 minute time window, I'm hardly able to drink water in 1 minute time window. At least you should give me one day advance warning that tomorrow at 12:30 there is going to be an earthquake, so that I can pack up my bags, go to the nearby hill station, chill out. At least that much advance warning should be given. But please understand, in the face of disaster, even that 1 minute is very precious. When you are inside a building and the alarm goes off and you know that in the next 1 minute an earthquake will happen, I'm sure you are smart enough not to start calling your friends, packing up your materials, then finishing up your lunch, that I have only 1 minute, I have to finish everything up. No, you will go to the nearest escape, a nearest open area, or a nearest area where you are assured that you will be protected. So that is how that disaster is managed. So this gives you an idea that if you know the basic features of a geographical phenomena, you can always bring about the aspect of disaster management along with it. So a brief summarization of this I will give you. And this is basically a depiction that when you have an S wave, when you have a P wave, so S wave travels like this, P waves travel through compression, rarefaction, compression, expansion. Okay, so this is the brief difference. P waves are the first waves to be hitting the Earth's surface, and their speed is generally 4.5 to 13 kilometer per second. S waves are 1.7 times roughly slower than P waves. So does not mean it is very, very slow. This will also move around 4 to 7 kilometer per second, right? But slower than P waves. P waves, they travel in a kind of a linear direction. So observe this: compression, rarefaction, compression, expansion here. That is how the P waves will travel. When we talk about the S waves, they travel in transversal direction in general. P waves and their travel is very similar to how sound waves travel. Sound waves also travel in the method of compression and rarefaction. Light waves, they end up behaving in a similar manner as you have the S waves. Just to give you an analogy, you don't have to learn this. Just to give you an analogy, these waves can travel through, P waves can travel through solid, liquid, and gas. S waves can travel through only solids. And one cardinal rule which is true for both these: denser the medium, faster the speed. I could not prevent from bringing a smile to the face because I came upon a question. The question is, if P waves travel in horizontal direction, how will they reach the surface? And it is partially because of the image, I guess, that you're getting an idea that P waves will travel in the horizontal direction. That is what I had told every one of you. Please don't get confused. But let's say we have been confused, don't worry about it. P waves will never travel in horizontal direction if this is the focus. They can travel in horizontal direction also. But here, first of all, when they are traveling to the epicenter, imagine these are the particles. This is the direction of wave propagation, and this will be the particle disturbance. Now, I hope that doubt doesn't prevail. How will they reach the surface? They will reach the surface. If, let's say, you have the planet, if, let's say, here you have the occurrence, now, even if they travel like this, won't they end up reaching somewhere? The impact will be very less or negligible, but here they will reach very quickly. Is that understood? Lakshmi, how S waves can't travel through liquids and gases? Lakshmi, that is primarily because look at the deviation that the particles are having. When the P waves or when the particles they are moving, let's say in this manner, which is not disturbing the space of the second particle. So as long as they are attached very closely in the case of the solid, they will end up influencing the second particle as they are moving. But let's say when they are far away, when the first particle moves, the second particle will not be disturbed that much, slightly maybe. Third particle, even lesser so. So the wave will dissipate as it propagates. Okay? And Kishan, we can conclude that if focus of earthquake is below asthenosphere, there is no S waves. No, we cannot conclude that because asthenosphere is semi-molten. It is not liquid. Semi-molten is different from liquid. Yes, we'll take a break now. We'll address few of the questions and we'll take a break. Okay. Why only S waves create main destruction? It is not the S waves which will create destruction. It is when the P and the S waves they combine, they hit, that is when the surface waves are generated. Destruction is caused by them. We'll come to this. Do S waves have more intensity? No. That is the S waves when they come, they bring the combined aspect of them, the combined impact of them. So that ends up hitting the surface. The surface ends up shaking like this, but that generates waves on the ground. Even S waves, Tajinder, can move in multiple directions. Remember the image that we have discussed here, that body waves will travel in multiple directions. They will end up reaching the surface first at epicenter, but they will travel in multiple different directions. Okay, is that understood? Why earthquakes are not happening near the sea and the oceans? They are happening near the sea and the oceans. Always, multiple earthquakes have occurred in the seas and the oceans. You were showing P waves going up from epicenter. Pintu, so imagine if this is the focus, here you have the particles. So the particles are moving like this in the case of S waves, and the disturbance is moving upwards. Okay? Which destructs more? Always the surface wave will have maximum destruction. P wave refers to the primary waves, S wave refers to the secondary waves. Okay? Is that clear? Good. These are body waves, my dear friend. Do Vanilla, do we able to complete the syllabus in 1 month? Not at this speed, but slowly and steadily when we'll pick up, we will be able to complete. Understand that in the initial stage of when you are getting introduced to a subject, it is very natural to have many doubts. Everything will appear to be new and you will have many curiosities as well. Slowly and steadily when you will settle down, when everything will become a kind of a familiarity in terms of listening to the newer terms and so on, you will settle down. It will be easier to cover it after that. So this is a natural progression. Okay. So now we take a break and we get back after the break. And that is when we continue with the surface waves. Okay. P and S waves, they disturb the surface, Ravindra, and that is when the surface waves are generated. A confirmation about the audio, please, guys. If the audio is clear and is available, kindly confirm the same. Thank you. So now we come to the portion of surface waves. Okay. So surface waves, the waves generated on the surface, as simple as that. Okay. Don't try to overcomplicate it. Waves generated on the surface. Now, why will the waves be generated on the surface? When we have the condition where the body waves end up disturbing the surface in itself is a continuous thing. So if the waves will end up disturbing the surface at one end, the disturbance will travel outwards. So these surface waves end up traveling outwards from the region of epicenter. Travel outwards from epicenter. Now, it is these waves which will cause the destruction that you see in the case of the earthquakes. Because it is these waves which will end up moving the Earth's surface in various different directions. For example, the Earth's surface will start behaving very differently when they experience that sudden shaking up. There will be a horizontal variation in terms of the Earth's surface. The land will start waving in a kind of a horizontal manner. The land will start having a kind of a vertical variation as well. So if a building, let's suppose, is standing here like this, now I hope that you are able to see this. So if a building is standing like this, let's say the surface is waving horizontally, maybe the building might be able to withstand that. If the surface is only moving, let's say, vertically, the building will experience much of a variation or a disturbance. But if both of them are combined, then the building will crumble. So there is a classification of the S waves also, even though not required for your general studies, but you should be aware of that. So S waves, they are classified dependent upon how the surface moves when the surface is disturbed. I will repeat. S waves are classified on the basis of how the surface moves when the surface is disturbed. So if the surface moves in a kind of a horizontal manner or in a kind of a vertical manner, that is why they are basically classified. That is how they are classified in the portion of love waves or Rayleigh waves. That is the general classification. And their speed is much slower. Speed is of the surface waves in general is much slower as compared to body waves. Is much slower as compared to body waves. Okay. Now, in the case of love wave, you will observe a kind of a horizontal variation in terms of the ground surface. You will have a horizontal variation. Whereas when we talk about the Rayleigh waves, in the case of Rayleigh waves, you will observe that here the movement is vertical. So that is where you have vertical variation. You have a situation of vertical variation. Overall, P waves are the fastest, followed by S waves, followed by love waves, followed by Rayleigh waves. Now, these seismic waves, they are very, very instrumental for us to be able to gauge the interior of the planet. So, that brings us to the concept of shadow zone. So, when we talk about a shadow zone, we'll talk about what a shadow zone is, how it is created. But these seismic waves, especially the body waves in general, and in fact about the body waves, when they travel through the body of the planet, they reach different parts of the planet. And when we experience that with the help of the observatories which are placed all across the planet, you have hundreds of these observatories, many of them lying above the ships, many of them placed above the ground surfaces across the globe. So that is where the measurement is done. Now, we know that what is the speed of the P and S waves. We know that time taken to reach that observatory station. So by that, we can guess an idea, or we can gain an idea about the regions through which they would have traveled through by looking at the density. Because we know one fact, that denser the medium, faster is the propagation, or faster is the movement, right? And slower the, or if the material, let's say, is less dense, then the speed will be very slow. So we know that. So by judging at the speed, or by judging the speed of the body waves, we can always gain a perspective about the materials that they have traveled through. For example, suppose, let's say we represent the planet like this. Now let's suppose here you have the occurrence of an earthquake. This is the focus. So these body waves, for the first, they will reach the epicenter very quickly. That is where the impact will be felt. But energy waves, they don't have a direction. Energy waves can move in all directions. Energy waves can travel and move through and move in all directions. Right? Now they are basically observed across the surface, measured through various observatories. That is why when you have an earthquake, let's say, which occurs in the region of Nepal, you have the United States government also issuing a statement almost immediately that this much magnitude earthquake has occurred in this epicenter. So that is because we are able to measure it out in various different areas. The energy which is transmitted, we are able to measure that energy significantly. Now, here we have to understand that energy travels in a certain method where the density of material also impacts the movement. For example, here, let us, I'm sure you would have studied about the portion of light and how light and sound they travel. So let's suppose we have a portion which is, let's say, glass, right? We do know that when light travels and hits the glass, that is where glass is a denser medium as compared to air. So light will experience a deviation. And again, after that, as it enters into the air, it enters, or it experiences a deviation again, what we refer to as refraction. So energy waves, they are impacted by the density of material through which they travel. We can think about that. Path of the energy waves are dependent on the medium that they travel through. Or can we reframe this entire aspect? Can we reframe the entire aspect as the energy waves, they will experience a deviation when they encounter a material of a different density? We can talk about it, or we can frame it like this, right? So we can frame it in a method that energy waves, in this case, let's take the seismic waves. So seismic waves experience a deviation as they encounter materials of different density. Now, what does that translate into, or what does that mean? So, let us imagine the entire situation again. So, here, let's suppose we have the planet. Now, we have seen that the planet has got various different layers associated with it. All these layers have variable densities. All these regions have variable densities. Now, in this, if let's say an earthquake has originated here, now the energy waves which will travel will reach the epicenter first. That is where the earthquake will be experienced. In other observatory stations, you will not be able to experience the shaking, but you will experience some amount of reading on the seismograph or on the Richter scale. So here, let's suppose you have the energy waves which are traveling like this. They will experience a deviation. As they are traveling through here, they will experience a deviation. They will experience a deviation here also. Because even when you go to the lower portion of mantle, or from the upper portion of crust to the lower portion of crust, the density initiates a change. Density exhibits a kind of a change. So that is why there will be a kind of a deviation which will be experienced, isn't it? So there is a deviation which is generally experienced. Now, outer core is liquid. So when the S waves, they encounter the liquid, they are not able to travel anymore. So that is why you will find that S waves, as soon as they encounter the outer core, that is where they start dissipating. Now that brings us to the concept of shadow zone. So when we talk about shadow zone, these are those places across the planet where these body waves are not to be measured, or the body waves are not observable. So anywhere where the earthquake occurs, anywhere wherever the focus is, from that point, if you subtend an angle that is from around 105 to 145 degree roughly on both sides, no P waves will be detected. The P waves are bending naturally. And in the case of S waves, as soon as they encounter the region of outer core, the S waves, they are completely absent. The S waves, they dissipate there. So that is why in the case of S waves, this entire region is where no S waves will be depicted or detected. So that region with respect to focus, where the P or the S waves are not to be detected, that is referred to as the shadow zone of an earthquake. Okay, let me write it down so that it is easier for you to be able to recollect as well. So, that portion where the P and S wave is not detected during an earthquake is known as a shadow zone. That is what is known as shadow zone. So, for example, let us analyze this furthermore. Here, in both these cases, The earthquake has occurred here, which will be generating the P waves and the S waves. The focus is there. So here, the body waves will travel throughout the body of the planet. So the body waves, they will travel throughout the body. Now there will be a natural bending of the waves. Why? Because as the energy waves, they move through a different medium, they experience a slight deviation. So as the energy waves, let's say they are moving from here to here, there will be a difference in density as they are moving from here to here. There will be a difference in density as they are moving from here to here. Difference in density. So that is why there is a kind of a natural bending of these P waves as well as S waves. So owing to that natural bending, you will come across a scenario where there are an angle, there is a particular portion with respect to the focus. In the case of the P waves, wherever the focus lies, around 105 to 145 degrees on both sides, that is where P waves are not to be experienced. So that is the shadow zone of the P waves. Now, the P waves, they will be able to travel through the outer core because the P waves can travel through solid, liquid, and gas. Now, as they will encounter or come across the region of inner core, what do you think will happen to the speed of the P waves? Will the speed increase? Will the speed decrease? Or will the speed remain unaffected? What do you think? Beautiful. The speed will increase. As soon as the P waves they will encounter the inner core, their speed will increase suddenly because the inner core is much more denser and it is a solid. And we know that with density, the speed tends to increase. So that is why P waves are able to transmit through the region of the core as well. And this is the exact property which was studied, which was observed, which was discovered by laymen in the early 1900s. And that is where you would have, if you recall what we studied last week, that the discontinuity between the outer and the inner core, that is referred to as Lehman discontinuity. So it was Lehman who discovered this fact that as the P waves are transmitting through the region of core, they are experiencing a sudden speeding of the movement. And that means if they are suddenly speeding up, there must be a material which is much more denser and which is solid. So that is why you have the P waves, or that is where the conclusion came that the inner core is in a solid state. Inner core is in a solid state. S waves, can they travel through that solid state? No. Why? Because in order to travel through the region here of inner core, the S waves have to travel through the liquid or the molten outer core. And S waves cannot travel through liquids. So the S waves, they are lost here itself. S wave cannot have an excuse that let me at least reach the inner core, then I will show you my ability. No. First, you have to travel through the liquid. If let's say any of you, you have a kind of a thing that you cannot clear prelims regardless of whatever you do, will anybody allow you to sit in the mains examination regardless of how talented you are? First, you clear the prelims, then you will attempt the mains. Here, the outer core is that barrier. Outer core is a molten liquid. So, because the S waves, they will get dissipated there itself. That is why the S waves will not be observed in this entirety of the region. So, that is what creates the shadow zone. So, in this, we can always say that shadow zone created by P wave or by S wave is much larger as compared to P waves. Okay. Shadow zone created by S waves is much larger as created by P waves. Now, here you might have a doubt that if the P waves is able to pass through solid, liquid, and gas, still you have a creation of shadow zone. Why? Then what is the benefit of having this kind of an all capable wave if still it will create a shadow zone? So the shadow zone in the P wave is created purely by the aspect of bending. If the bending would not have happened, no shadow zone. But the bending will happen because it is traveling through, or the deviation is happening because it is traveling through materials of different densities. That is why in this case you have a shadow zone created by P waves as well as S waves. Okay. And yes, sometimes you will find in certain books 103, sometimes 105. So that is basically the case of the shadow zone. Both of them, you can think about it. Okay, right? So is that understood? Four shocks will include both P and S waves. Is that understood? Okay, very good. In one of the previous classes, we have discussed that outer core is not consistent liquid, but it is a liquid nonetheless, Deepika. Understand that liquid might have a greater density somewhere, lesser density somewhere. That liquid might have a uneven distribution, but it is liquid nonetheless. So that is why the waves are unable to travel. And Aarti, as I told you, you can take any of them. And Lakshmi, why S waves can't travel through the solid core? I hope you got the answer for that. Okay. And why speed of surface waves are slower? Because the density of the surface is very, very less as compared to the interior. That is why, as the surface is supposed to be moved not because direct energy released from focus, but because of the energy received at epicenter. So some amount of energy is reduced as well. So that is why the speed is generally slower. Okay, right? And does density directly proportional to speed applies both to P and S waves? Yes. Can S waves with low density crust can cause more destruction? It depends. It depends upon the depth. It depends on multiple factors. Shallow, yes. Rayleigh waves, they cause much more destruction. PPT and book that is provided is more than sufficient, provided you are attentive in the sessions, because in the sessions, many of the times we will be discussing concepts that you will not find in any of the books. So pay attention in the session. It should be more than sufficient. Which density is higher, P and S wave? See, P and S wave, they don't have a density on their own. These are energy waves which are traveling. So please understand that P wave doesn't have a density, S wave doesn't have a density. Okay, Meenu? Both of them are energy waves. They travel through materials of different density. You cannot have the question that which has greater density, light wave or sound wave. They travel through materials of different density. Okay? In shadow zone, there will be low intensity. Okay. Here, please understand. If let's say we are saying this is the focus, this is the shadow zone, here you will not even experience any earthquake, right? Because in all fairness, this would be thousands of kilometers away from where the epicenter is. Okay. It might very well happen that the epicenter is in Nepal and this shadow zone is somewhere in the region of Atlantic Ocean. So there you will not even experience that. Okay, right? Kishan S wave is known as shear waves. Yes. Why energy reaches faster at epicenter? Because it is the shortest distance, but perpendicular. S wave is the body wave. Palak, surface wave is generated on the surface. Density of Earth increases with depth, then Y waves are refracting away from center. Okay. Again, Pay attention, listen to this carefully. This all breeds these all many of these questions, they are breeding from the fact that something might be mistaken here. Otherwise, the concept in this part is so foolproof. So listen to this carefully. If the P waves are traveling from here to here, they are traveling through materials of greater density, right? Now, as they are moving like this, then they will, for a brief moment, encounter materials of same density. Then materials of lesser density will come into the picture. Slowly and steadily, they are moving to the surface. So, what is the kind of a deviation that you see? Isn't it away from the center? Okay. So, that is how it is. Not only the S waves which help us understand the interior structure, it is a combined behavior of these body waves which help us understand the entire structure, interior structure of the planet. Okay. Shadow zone on the Earth's surface do not experience earthquake. Again, I will reiterate. If you have an earthquake which occurs in India, will US experience the impact of it? Absolutely not. Right? So shadow zones are that far away. Shadow zones are purely for observational processes. They are not experienced. So when you have a shadow zone in that area, the body waves won't be reaching. Even if the body waves, let's say, are reaching here, they are reaching here. Even people in these areas, they won't be experiencing any earthquake. Even people in these areas, they won't be experiencing any earthquake. Because by the time that the body waves will reach here, their quantum, their magnitude would have reduced quite significantly. That is why the P waves and the S waves, the shadow zones that you are talking about, these shadow zones are very, very far away from the region of the epicenter, very far away, very distantly far away. Okay, I hope that is understood, Shalu. Is there any place where permanently shadow zone? No. Only the epicenter will receive earthquake and the region around it, yes. Does P wave have more refraction in the semi molten or liquid state? Depending upon the speed that you have, they will end up behaving ever so slightly different. Okay. So, this is also the property by which many of the times that you come across the fact that, let's say, a nuclear explosion or a nuclear test has been performed by North Korea in full secrecy. How do you think the world gets to know about it? When you had the Pokhran test, the nuclear test which was conducted by India, how do you think within minutes even United States got to know about it, and entire world got to know about it? It is because of this property. When you carry out such massive explosions, that also provides a lot of energy which travels through the surface and through the interior. It is by measuring these at various different observatory stations that the scientists, the geologists, they are able to make a difference that whether it is an earthquake or it is a kind of a man-made explosion creating that energy. For example, we have seen how the seismograph behaves when you have an earthquake. When you have an earthquake, the seismograph will end up having a slight deviation prior to the main event and maybe a slight deviation much later on. But when you have, let's say, this a nuclear explosion, etc., which is caused, the seismograph will end up indicating just a brief movement, an isolated brief movement, which tells you there is no adjustment of the rocks before or after. That means it is a man-made explosion. And this is how we use this particular technique to also understand which are the weaker areas across the planet. Where is it that the plate boundary lies? Because wherever the plate is discontinuous, wherever you have a plate boundary, immediately it will escape through that region, and there you will have very frequent earthquakes occurring as well. So this concept of the seismic waves being able to travel through the interior of the earth, that gives us a lot of information about what the interior is actually constituted or composed of. Okay, right? So Speed of these waves we have already seen. Speed of P waves roughly around 4 to 13 kilometer per second. Speed of S waves generally is 1.7 times slower than that. Now, let us talk about the concept of a tsunami. Tsunami is basically Japanese for a very giant wave. A very giant wave that is referred to as a tsunami. So, why is it, where is it, and how is it that tsunami is experienced? So, tsunamis will always be experienced whenever you have a high magnitude or they are triggered by high magnitude earthquake in ocean surface. That will trigger a massive tsunami. Now, here again, I will repeat the question that I asked you last week as well. And I will launch a poll for that so that you don't flood this comment section. So, I will launch a poll for that. The question is that which of this will be considered as a surface? So, if I have, let's say, this as the ocean, okay? Now, let me frame the question. So, I'll launch a poll for this. So, here, just a brief moment. I'll give you 15 seconds to let me know which amongst these is considered to be the surface. Is it A or is it B? Which of these is considered to be the surface of the planet? Let me know. Very good. Beautiful. Majority of you have given the correct answer. This is A will be considered as a surface. The top of the ocean will never be considered as a surface. It is just present on the surface. So whenever, let's suppose, we have underwater conditions, in the sense that we have oceanic convergence or oceanic continental convergence. So in the case when we have an oceanic continental convergence, we have the continental landmass and the oceanic landmass is going underneath. On top of it, you have all the water which is present. Now, as the oceanic crust is going underneath, this motion will never be smooth. This motion will be very staggered, right? Very irregular because of the frictional force which is offered. Now, this will cause an earthquake. This will release energy somewhere, let's say here. So, in this case, just replicating this on the image that you see on your screen, let's suppose there is an energy released from here. This is the focus. This is at a depth of, let's say, 50 kilometers from the surface. Let's assume it is at a depth of 50 kilometers from the surface. Now the bottom will significantly get disturbed, isn't it? The ocean bottom, that is the surface of the planet, that has gotten disturbed. Now, as the surface in itself gets disturbed, what will happen to the water, kilometer thick water which is present there? That water will also get disturbed. And that disturbance, first of all, will travel straight up from the point of the epicenter of earthquake. Epicenter will be this one. So from epicenter, it will start traveling significantly upward. And water will generate a very large deviation and it will start spreading outwards. So that is what is referred to as a tsunami. When we talk about the December 26, 2004 tsunami, which ravaged, destroyed the region of South Asia, that tsunami was triggered by an earthquake which occurred across the region of the Sumatran Trench. To the south of Andaman Nicobar Islands, that is where you had that earthquake and the epicenter of the earthquake. When we talk about the tsunami which destroyed or caused a lot of devastation in Japan, causing the Fukushima disaster, that was because of a massive earthquake which occurred across the subduction zone of the Pacific plate. So, wherever you have massive underwater earthquakes which occur, that is something which is regarded as, or that is something which generates very large waves, and those large waves are regarded as tsunamis. Okay, most of the times you will observe these tsunamis occurring because of earthquake occurring at the zone of convergence of ocean and ocean continent. Okay, right now, don't you think through trenches water go inside rather than uplifting? Okay, this you are talking about the water moving through here. Some water might seep through here. I'm talking about the disturbance. For example, take a mug of water, take a jar of water. Without touching the surface, hold a punch or throw a punch at the base of the mug. The surface water will get spilled off. Why? Because you are disturbing the base. That means you are disturbing the water above. So it will get spilled off. So that is basically how you have the occurrence of tsunamis as well. Okay. Most of the times, Sachin, the origin of the tsunami is observed near the trenches. Okay. Changes, how sea waves are caused, we'll come to it when we come to oceanography. In case of tsunami, only P wave will cause destruction. Why? Why will P? In case of tsunami, you will have the see, tsunami is caused by a giant wave, and that wave is generated because of an earthquake. So when you have an earthquake occurring here, this will be the focus, this will be the epicenter. Okay, this is the focus, this is the epicenter. So if the energy is released from focus, that energy will be reaching the epicenter. From here, the surface wave will be generated that will disturb the entire area, and that is how the water will get disturbed. Okay, all of you who are getting a clue or an idea that S waves do not get created. Okay, fair enough. Let us delve deeper into this. So, when we talk about tsunamis, these are very giant waves created due to an earthquake occurring underwater. Now, why will an earthquake occur under the ocean? Earthquake occurs where the earthquake will occur under ocean. Underneath oceans, earthquakes are triggered by convergence, that is ocean or ocean continent. Okay, or even by transform movement. As of now, just be aware of these two reasons for earthquake under ocean. Right? Now, so this is basically a repetition of what we have already studied under plate tectonics. But let's assume ocean-ocean convergence. When we talk about ocean-ocean convergence. Now that is a portion which is underwater. The plate movement is underwater. Water is not regarded as the surface. So here, when you have one oceanic plate which is sinking underneath the other oceanic plate, now that motion will not be smooth. That motion will be disturbed. It will get staggered, right? That motion will never be smooth. So let's suppose as the plates are moving down, let's suppose there is the occurrence of an earthquake here. This is, let's suppose, the region of the focus. Now, first of all, body waves will travel, isn't it? Whenever you have the occurrence, the body waves, they end up traveling significantly. So the body waves will travel. So here, let's represent the body waves with a black color. Body waves will travel here through this entire region. They will reach the surface. This is the surface. The body waves will disturb the surface. So here in the body waves, you will have the presence of both P and S waves. Right? Now these P and S waves, they will hit the epicenter. This will be the portion of epicenter. Now from here, there will be a variation. There will be generation of a surface wave also in this region. The ground surface, the underwater surface, that will get variate or that will get disturbed. Now, in return of that, as the water or as the land underneath all that water, if that land is shaking, what will happen to the water above? Will it remain impervious to it? Or do you think that water will also be disturbed? The water will also be disturbed. Here, first of all, what will happen is here, this water level in this particular region that will suddenly go up and it will go down as well because of the shaking of the underground region or submarine region. There will be water which will immediately go up and down, and that will generate a wave which will then move out in all different directions. It is this wave that we refer to as a tsunami. When it hits the coastline, that is where significant amount of destruction is caused. That is what is referred to as tsunami. Okay, I hope now it is understood that whether S waves will travel or not. Is that clear? Good. So now we proceed further with the aspect of. So all those of you who make it a point to write it immediately that it is not clear, I expect the minimum that when it is clear, have a confirmation of the that as well. S waves can't travel. Where S waves can't travel? Why do you think I asked the question that what is the surface? Which is the surface? Did I want to see that whether you have an idea about what we talked about last week or not? S waves are body waves. Body waves will travel where? through the body of the planet, not along the surface of the planet. So this is the surface. This is what is the surface. This is the surface. So will the S waves travel beyond the surface? No. This portion that you consider, the water that you consider, if you consider that that S waves cannot travel through liquid, so S waves are not traveling through the water. P waves are also not traveling here. Here neither P waves are traveling in the water body nor S waves are traveling, because that is not the planet, that is not considered to be the body of the planet. Body waves will travel only in the body, interior body, that is from the focus to the surface. Body waves will travel only through from focus to the surface. That is the only portion in which the body wave can travel. This is the surface, this is the focus. So S waves will be present or not? It will be present. Here you don't have even surface waves which are traveling. Don't think of tsunamis as surface waves phenomena of an earthquake. Tsunami is a water disturbance which is created because the underwater, this is the surface. Okay, is that clear now? Okay. Again, after 5 seconds, I will get a kind of a question that this does not travel, S waves does not travel, or body waves does not travel. Okay. Now we come across the geographical distribution of earthquakes. Where is it that the earthquakes generally are observed? So when we talk about the geographical distribution of earthquakes, majorly, where is it that the earthquakes occur? In majority of the cases, the earthquakes will occur at plate boundaries. Wherever you have plate boundaries, the earthquakes will end up occurring. Okay? Wherever you have the presence of plate boundaries, earthquakes will occur. So, other regions also where you have the weaker areas, the fault lines, the fault zones, etc., there also sometimes the earthquakes can occur. But when we talk about plate boundaries, when we talk about the plate boundary, here, earthquakes will occur across all the different types of plates. So, across convergent, across divergent, and even across transform plate boundaries. Now, out of these, you will observe that convergent and transform ones, these are of high magnitude. Why? Because it is across the convergent and the transform plate boundaries where the plates, they will try to rub against each other, where they will try to move with respect to each other. That is where they will experience maximum amount of resistance. That is where the speed will be significantly slowed down as well. So that is where when they overcome that resistance, there will be a lot of energy which will be released in the process. In the case of divergent boundary, the plates are already moving away. So as the plates are moving away, the earthquake, why will it be observed? So in divergent boundaries, the earthquake is observed typically because as the molten materials, they try to come out, many of the times they push on the surface, they exert a pressure on the surface, and that induces an earthquake in that region. So already the plates are moving away in the case of divergent plate boundaries. The molten materials, they are trying to come out, but sometimes they will push the surface, creating a low intensity and a low magnitude earthquake. So that is why earthquake across convergent and transform, they are of high magnitude, and this will be low magnitude. Okay. So that is basically at the plate boundaries where you experience the earthquake. Other than this, earthquakes will also be observed where you have movement of rocks across any crack which has developed, any fault line which has developed. So whenever there is a movement of rock at that region, there also you will experience earthquakes. So movement of rocks across the cracks or faults present. That is also where earthquakes will be observed, as the rocks will try to move in the region of a crack, if they will try to readjust themselves in any particular region, an earthquake will be induced. Sometimes, otherwise, also, whenever you have a massive volcanic eruption, and in the volcanic eruption, molten materials with a lot of gases, they are thrown upwards. So that molten material, along with a lot of gases, when they are thrown upwards, that will end up shaking the Earth's surface. So that is what is also referred to as, or that is something which also ends up causing earthquakes. So other than this, you also will experience earthquakes whenever you have massive volcanic eruption. For example, last year in January 2022, we had a very massive earthquake which occurred at the island region of Tonga in South Pacific. Or we had a very massive volcanic eruption, one of the most powerful volcanic eruption that we have experienced since 1991 across the planet. So you had a very significantly massive volcanic eruption at Tonga. Now, as the molten material they tried to push to the surface, they ended up shaking the Earth's surface and created a created an earthquake. That earthquake, which was created in South Pacific, generated a tsunami, and that tsunami hit the New Zealand coastline. That tsunami crossed the Pacific and even impacted the North American and South American land masses. That is where the impact was also felt. So that is basically how an earthquake occurs. Now, if we know the reason why the earthquake occurs, so we can basically end up committing to an area where the earthquake is frequented. So basically, the earthquake will be frequented majorly across these areas. Movement across the rocks or the cracks, that is not very predominant. So across the globe, if you have to go for the regionalization of the earthquake, so earthquake occurs in two main regions. You have the circum-Pacific earthquake belt, what is also something that we have studied as Pacific Ring of Fire, and then you have the Mediterranean Asia earthquake belt. So in both of these, you will observe an absolute zone of convergence in both of these cases. Okay, so if you observe this, this is the circum-Pacific earthquake zone. The circum-Pacific earthquake zone, or the Pacific Ring of Fire. Other than that, this is basically the Mediterranean Asia, starting from the region of Mediterranean and moving all the way to the region of the Himalayas. This is where you have massive earthquakes across both these ends. Across both these ends, we have massive earthquakes which end up occurring. So that is basically the prime zone. Other than that, you also have minor earthquakes occurring at the region where you have divergence. Excuse me. Other than that, we will also have minor earthquakes wherever we have divergences. So, for example, in this region, mid-Atlantic ridge, you have divergences. Here, you have a transform plate, right? As it is diverging, here you have the presence of a transform plate. Here also you will have minor earthquake. So here also you have divergence. So here also minor earthquake will occur. So all these areas will receive minor earthquakes. So if a question is asked that discuss about the geographical distribution of earthquakes across the globe, how do you attempt that question? So there, first of all, very briefly, you talk about the fact that how the earthquakes, or where is it that the earthquakes occur. So at the plate boundaries, at the earth, or at the volcanic zones, across fault lines. So you discuss about that. After that, you do the zonation of it. So you have massive earthquakes which are occurred across the circum-Pacific earthquake belt, across the Mediterranean Asia earthquake belt. And then you have minor earthquakes which are also experienced across the divergence regions, right? And explain the divergence regions, the mid-oceanic ridges that you have, the mid-Atlantic ridge, for example, the East Pacific rise, for example, that is the Chilean rise, for example. These ridges you can talk about. And thereby, you can talk about that why earthquake happens in this region. So earthquake happens in the point of convergence as the plates they try to subduct under one another. That movement is going to be rough, inducing a kind of an earthquake. Okay? So that is basically the aspect of global distribution of earthquake. And you will find a kind of a similarity in the sense that basically whenever you talk about even the volcanic eruption will tend to frequent those areas wherever you have plate boundaries. Now, it is this Tonga eruption that I was talking about that induced a large tsunami. It is said that when you had a massive eruption here at Krakatau off the coast of Indonesia, west coast of Indonesia, way back in 1883, that also had instigated such a violent tsunami that had also caused a lot of destruction in South Asia. So that is basically how sometimes even volcanoes can induce massive earthquakes. Should example be mentioned as well? If you can, nothing as good. It will authenticate your answer. Then we come to earthquake zones of India. So across the country, there is a zonation of the region, or across the entire country, there is a zonation which is done in order to gain an idea about what is the probability of earthquake occurring in that region. So you have a zonation from zone 2 to zone 5. There is no zone 1. There is no zone 1, and this keeps on getting updated very frequently. And there is no zone 1 primarily because of the fact that no area is said to be absolutely free from the probability of occurrence of an earthquake. Because you never know that there might exist a fault line in that region, or a fault line might develop, a crack might develop in that area. For example, for a large part, we have had an understanding that Peninsula Plateau is made up of a stable rock system which is very old, which has got no crack, so there will be no earthquake. That is why when Latur earthquake struck us, Latur in Maharashtra, it caught everybody by surprise that how come an earthquake can strike in the peninsular part of the country? Because it is expected that earthquakes have always occurred, will always occur in the region of Himalayas, will always occur in the region of Gujarat. But how come in the region of Peninsular Plateau? Later on, upon further investigation by geologists, it was found out that there has been in existence a crack in the region of the Peninsular Plateau right since the time when Indian landmass had collided with the Eurasian landmass. So that is why, while the ground surface is studied continuously, but no area can be said to be absolutely improbable for a region of an earthquake. So that is why the zonation is zone 2 to zone 5. Now, here, typical regions which experience or which will have an expectation of very high magnitude earthquakes, these are basically the Himalayan zones. Himalayan zones. And then the region of Gujarat. Why the region of Gujarat? In the region of Gujarat, basically, because it is here that you have the boundary zone of three plates. Which are those plates? Indian plate, Eurasian plate, and the Arabian plate. So any movement across any of these plates will end up having an earthquake there. And why the region of Himalayas? That is where maximum compression is happening. There are cracks which have developed between the mountains, and there is a movement happening between those cracks. And that is what is initiating and inducing an earthquake. Now, even within the Himalayas, observe the region which are prone to earthquakes. So here you will observe the region, for example, North Bihar, region, for example, Uttarakhand, region, for example, parts of Himachal, parts of Jammu Kashmir, and significant portion of Northeast. So in the northeastern region, why is it that we have so much higher expectation of an earthquake, much more from the other expectation or other areas across the northern plains or across the Himalayan region? That is because as the Indian plate collided, it is here that you have maximum compression of the rocks. It is here that you have maximum compression of rocks. All these rocks, they are significantly compressed, they have been significantly deformed. That is why it is expected that in the next 100 years, this entire region will experience very massive and multiple of these earthquakes to be occurring. Many massive earthquakes of magnitude 8 and above will be required in order for the rocks to be able to gain their natural state, in order to get rid of all the energy which has been built up in these rocks, in many of the cases for many different centuries. Whenever an earthquake occurs, there's a release of energy. That means the energy that the rocks have trapped, that is released. So always the rocks will try to get rid of the energy. But after a prolonged deformation, slowly and steadily, the energy keeps on getting trapped. The potential energy keeps on getting built up. So if a long time has passed in an area where the rocks have been deformed and there has not been an earthquake for a long time, that means that region is due for a very massive earthquake. So that is how we get to know that which particular region can experience a massive earthquake. Okay. So here, for example, so these are the regions where you have these particular earthquakes or zonation of earthquakes. So in the region of Gujarat, you have a tri-junction of the plates. Which plates? Indian plate, Eurasian plate, and the Arabian plate. Okay. That is why in these areas, in high altitude or in these mountainous areas, it is always advisable to go for minimum level of construction, because already the rocks are so very deformed. Any further deformation can lead to the entire aspect coming crashing down. Okay. Now here we come to induced seismicity or induced earthquakes. That is the earthquakes which are created and caused by human interference. That is induced seismicity or induced earthquakes. So earthquakes caused by human interference. So here, when we talk about human interference, so whenever we have the case of hydrocarbon extraction of hydrocarbon, that is fossil fuels, crude oil, even natural gas. Now, I don't know how many of us are aware of that extraction process. Nonetheless, it is not important for us to know that extraction process anyways. So I'll just give you a brief about how that hydrocarbon extraction takes place. So generally what you will observe is you have an installation of two pipes. Two pipes are drilled and they are installed. So let's suppose in an area where you have lot of oil. So oil is basically something which is absorbed in the rocks. In the porous rocks, that is where the oil ends up getting accumulated. So you cannot simply dip a bucket or a bore well and you start pulling out. So what do you do in this? So you dig two pipes. From one, you put in very high pressured air and water. High pressure water. Now what it does is it increases the pressure underground. And that pressure, when it is increased, it pushes it towards the other pipe which sucks it out, which is the extraction point. So all the gases, etc., they try to rush in through that pipe. And in that process, many of the times they end up shaking the Earth's surface. That is an induced seismicity. Many of the times, this extraction process is so violent that the pressure exerted on the ground creates a huge blast. This entire thing that you see, that is blown off to bits. Recently, that is last year, during one of these extractions in the region of Assam, it simply caught fire, and that fire continued for a very long period of time. It is not easy to get rid of that fire also. So that is how, while the gases, the crude oil, etc., everything rushes out with huge speed and huge pressure. After some point of time, the flow stabilizes, then you put a cap to it, then you put a proper extraction mechanism so that periodically it is extracted in regularly desired volume. But in the first stage, in the initial stage of extraction, it always escapes with very high pressure that shakes the Earth's surface. Then you have the construction of the dams, large dams. So whenever you have a large dam, let's suppose you have the land area, and here, let us suppose you have the dam. Okay. So basically, a dam will have a reservoir also. So it is going to have a reservoir also, a large reservoir. Now, this dam that you construct, oftentimes you will find that dams are constructed, or these large reservoirs, they are created around the region of hilly or mountainous terrain, oftentimes, because that provides an ease of water storage, water capacity as well. Now, in the case of this dam, it is made up of reinforced concrete. It is not a light material, it is a very heavy material, reinforced concrete. So that reinforced concrete and the entire water column above this, so that will be exerting pressure, significant amount of pressure on the ground surface. So the rocks on the ground surface, under the ground surface, they start getting deformed. Many of the times, the rocks try to regain their natural state. So if the rocks are deformed, they try to regain their natural state, shaking up the surface. It can lead to an earthquake. But in majority of the cases, something else happens. And in majority of the cases, owing to the weight induced, there is a development of a crack or a fault line which happens. A crack or a fault line develops. Now, due to the pressure or due to the weight, that is why the fault line has developed. Of a fault due to weight. Now you have water which is stored. All that water which is stored. So all that water starts puncturing through, entering it. Now, water acts as a lubricant. Now, when water enters into and forms a layer within those cracks, that makes the movement of the surface very easy with respect to each other. And that is when you will observe that there is a sudden motion sometimes inducing an earthquake. Example of this that we have experienced in India, we have the example of Koyna Dam induced earthquake, the Koyna Dam disaster. So, example, you have Koyna Dam induced earthquake. This is also what is referred to as RIS, or reservoir induced seismicity. That is what is also referred to as RIS, or reservoir induced seismicity. Now, then after that, mining operations. So, any of us who have been living in mining towns across the country, you would have experienced this, that every day there is a periodic explosion with the help of dynamites. So, with the help of explosives, controlled explosives, you end up blasting through the surface, you end up blasting the underground. Why? So that all those rocks they get loosened, so that the extraction becomes easier. So, when you have mining operation, that brings about, or that entails, a kind of a controlled explosion. Those of you who live in a mining town or a mining area, you would experience that it is, many of the cases, it is done twice a day, once in the morning, once in the evening, for the morning shift and for the evening shift. So that is basically a kind of a controlled explosion, which brings about a kind of a shaking of the ground surface. Okay, so I'll repeat the entire process once again. So, during the case of hydrocarbon extraction, what happens is that you are going to inject very high pressure and very high pressured water, a high pressured air and water from one inlet, so that all the oil plus gas that rushes out through the extraction pipe. Now, as they start rushing out, that is when it starts in undergoing a shaking, or undertaking a shaking of the earth's surface, and that is what brings about induced seismicity. Then, when we have the dam construction, when you have large dams, large reservoirs, they will exert a weight on the ground, and that is where the rocks will get deformed quite significantly. When the rocks will get deformed sufficiently, they will try to regain their original state or shape. That will also bring about an earthquake. Or many of the times, due to the weight that is created, cracks develop under the ground. And when the cracks they develop underground, that is when water starts penetrating through those cracks, creating a kind of a lubrication of sorts, so that the rocks they start sliding against each other, inducing a kind of an earthquake. Then mining operations, controlled explosion, they will also end up shaking the earth's surface, creating an earthquake. Okay, so that is about the earthquakes. Volcanoes we will cover tomorrow. Just to give you a brief recap of the portion that we have covered till now, earthquake is what? Shaking of the earth's surface. Earth's surface. Why? As rocks in the region of the crust, or even consider the entire lithosphere, move with respect to each other, there is resistance. When the resistance is overcome, massive energy is released. Now, you have the focus as the origin of an earthquake. So I have one of you who is so very punctual in the session. Every day at around 9:29 exactly, I get a message when the class will be over. So now we will not be covering any new topic in the class, my dear friend. You're free to leave. And also, let me tell you, basically, please try to gain as much as we are trying to cover in the session. I hope you have a pen and paper with you. So please don't have a demand that write everything on the slide, all the examples that you have written, write it on the slide. That is why you have a pen and paper. You are not a mute spectator there. Okay, try to take it in a constructive manner. I will not be repeating it every class, but I expect a level of discipline at your end as well. So try to note it down wherever you have any kind of examples which are being thrown around in the class or new concept that you find it newer in the class. Try to note it down. Do a bit of hard work on your own. Trust me, it will be much more rewarding. After all, you are trying to become an IAS officer. Do you think you'll become an IAS officer just by staring at the screen, simply sitting there and thinking that answer writing will also come, all the aspects will also come? Do you think that will happen? So that is not going to happen. So all those who has submitted these requests, it is for you. So that have the expectation as much is given. So you will have the recordings of the sessions also which are available to you. Okay, so you can revise it. So here, I hope that is understood. I'll not take the name because that is not proper. Origin of earthquake, release of energy. Epicenter, perpendicular to focus. Impact of earthquake is first observed here. Then seismic waves. Energy travels through waves. You have body waves, P, S. This is faster. You have surface wave, love, Rayleigh. This is horizontal movement, and this is vertical. Then you have shadow zone. Areas where body waves are not detected. P wave, S wave, shadow zone is larger. Okay. So this is the broader gist of the basics. Then we had discussed about the portion of the global distribution, how the property of body waves traveling through the entirety of the structure helps us basically get an idea about the interior structure of the planet as well. And also the aspect about induced seismicity. So that is all that you are required to know about earthquakes from general studies perspective, and that shall be more than sufficient for the requirement of your exams as well. That is where we'll end the session. I'll take a couple of questions and then we'll end the session. Can hydrocarbon extraction cause tsunami? No, my dear friend. Deccan Plateau formed due to volcanic eruption? Yes, Pravasini. How cracks lead to earthquakes? So wherever you have cracks, the rocks will tend to, so not all the cracks will have a kind of a movement of the rocks. You have the case of a fault line, which is a crack where the rocks will move. So that is where, as the rocks they try to move, they will induce an earthquake. Why there is no zone 1 in the case of an earth zonation in India? That is because no region is said to be absolutely free from impact of earthquake. Earlier in the previous marking or designation, there was a zone 1, but it was removed because it is expected that any region or every region might end up experiencing an earthquake. How to read the world map related to all this type of topic? So whenever you come to the portion of these particular topics, here we have talked about the global distribution. So take a look at the world map, take a look at the regions where the earthquakes have occurred. That is how automatically your understanding will increase. Why do Northeast India come under zone 5? Because that is where maximum deformation has happened, maximum compression of the rocks have happened, as you have the Indian plate which is colliding. When we come to the portion of Indian geography, I'll tell you about how that convergence is happening. What kind of deformation of rocks in dam construction? It is a kind of a significant compression, okay, a significant tear which is also created. Then Shalu, in earthquake caused in dam due to rocks getting in original form, release of energy happen. Yes. So Shalu, that can also induce an earthquake, and oftentimes due to the weight of the dam structure and the reservoir itself, that also induces a crack, which can bring about a motion and motion of the rocks with respect to each other. So that is that sliding which will be initiated, that can also give rise to an earthquake. Okay, and P wave shadow zone is due to refraction as they travel from one medium to another. Perfectly correct, Prince. Okay, Shreyansh, please feel free to write to us at IS Live. We'll get back to you. Okay, induced earthquake, Minu, is basically when you have an earthquake created due to a human interference or human action. That is basically an induced earthquake. Okay. How to write mains answer regarding global distribution of earthquake. So basically, see, for the global distribution of earthquake, first of all, if you have to write the answer, the introduction should consist of the part that earthquakes are caused because of relative movement of rocks or lithospheric regions with respect to each other. And that is where you can talk about the aspect that the generally observed across the plate boundaries and also across the fault lines and regions of volcanic eruption. That will finish your introduction. Then after that, in the body part, you can write that the zonation of earthquakes can be done across the regions which are very prone to earthquakes. So accordingly, you can write the circum-Pacific ring of fire and the Mediterranean Asia belt, and in bracket in both of these you can write high magnitude earthquakes. So there, after that, each of these zones, so you need to draw the world map depicting these zones. In each of these zones, then you need to be able to write that why the earthquakes are happening, what type of convergence is leading to it. Then after that, again, you can write about, in the case of circum-Pacific ring of fire itself, around the region of California, you have a transform plate movement that creates a kind of the transform fault, which induces an earthquake. So you get an opportunity to talk about the transform as well as convergence in these two zones. Then after that, give another column and talk about another subheading and talk about regions of divergences and low magnitude. So there talk about a couple of mid-oceanic ridges, that is mid-Atlantic ridge, and also talk about the portion of East Pacific rise and talk about how their earthquake is occurred or observed. Okay. Madhur, my dear friend, I was not able to find the name. So by what name did you send a mail? Many of the time, I don't know. I'll take a look at it again because I tried searching for your mail. I could not get it. So send it again. Okay, Madhur Sayal. Okay, I'll take a look at it. Uh, then Sunita, during the formation of tsunami, seamounts and volcanic islands are also formed. No, 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 no. Seamounts and volcanic islands, they are created volcanic eruptions. Tsunami is due to an earthquake. Very different. Which map should we have in our room? A physical map of the world and a political map, more than sufficient. Sometimes dam itself collapse and floods the nearby area. That is also correct. Deepika, um, extreme gratitude for the very kind words, and I hope that the sessions they turn out to be as productive. And RIS is reservoir induced seismicity. Reservoir induced seismicity, Nisarg. And okay, you want a mains question. Tomorrow I'll give you the mains question. If today you want to write a mains question, write about the global distribution of earthquakes. Okay. Is diagram required for mains answer? Absolutely yes. Absolutely yes. For every mains question of geography, a diagram is a must. And should we write questions from NCRT exercises after reading the same chapter? No. See, NCRT questions, they are very childish in nature in the sense the subjective questions that you have. Take up the, I hope you would have written the 5 questions that were put in the subjective test on the weekend. Try writing that. And all the previous year questions that we are discussing, try writing that as well. So when we are done with geomorphology, we will be discussing a set of 5 to 6 previous year question, mains question. Try writing about that. Okay. Right. So that is where I'll restrict the session. How earthquake, okay, last question. How earthquake due to divergent boundary? Because as the plates, they are moving away, molten materials, they try to puncture through the surface. So it is in that push sometimes that slight shaking of the surface happens. That is how it induces an earthquake. Okay. So that is where I'll restrict the session here for today. I hope you have extracted something out of it, something that you did not know before. Tomorrow, when we come, we'll complete it. The portion of volcanoes, the intrusive landforms, concepts of hotspots, mantle plumes, etc., will be covered tomorrow. Before that, I would request you kindly go for a revision of the plate tectonics portion. In many of your cases, I have found out that by looking at the question that there is some doubt in that. Kindly try to revise it. Volcanoes will be much easier to understand. And then we'll move at exogenic forces in the creation of the various landforms. So till we meet again tomorrow, take care of yourself. Goodbye and have a nice day. Thank you.